A large online retail company overlooks its security operations, failing to implement robust monitoring, threat protection, and incident response measures. This oversight weakens the company's security posture, making it susceptible to cyber threats. You can well imagine the ramification. An attacker identifies the vulnerability and breaches their systems. Due to the lack of effective security monitoring, the intrusion goes undetected and the attacker exfiltrates sensitive customer data. This compromise of customer data leads to substantial financial losses, reputational damage, and legal implications. You are a security engineer at a multinational organization. Your organization's reputation depends on its system's performance, reliability, and security. You must monitor your systems closely to identify any performance problems or attacks before they affect users. What proactive measures will you take to prevent a similar scenario in your organization? Hello, and welcome to Manage Security Operations, the 6th course in the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. My name is Ramanujan Srinivasan, and I've been a technologist for the past 25 years. I'm a certified cloud and security architect and help Fortune 500 companies formulate strategies and implement security solutions. I'll be guiding you through this course. In this course, you will learn to deploy Azure Monitor and manage security operations using Microsoft solutions such as Microsoft Defender for Cloud and Microsoft Sentinel. We have organized the course content into 4 weeks. In the first week, you will learn about configuring and managing Azure Monitor. In the second week, you will learn how to deploy, customize, and configure Microsoft Defender for Cloud to secure your cloud environments. In the third week, you will learn to configure and monitor Microsoft Sentinel to detect and respond to security threats. In the fourth and final week, you will do a project based on a real-life scenario and take a course-level graded assessment. Let's dive deep into what each of these weeks will cover. In the first week, you will learn about Azure Monitor, a comprehensive monitoring service that helps organizations gain insights into the performance of all their Azure resources. You will learn about the fundamental data types that Azure Monitor uses, the monitoring options available in Azure, and the features of Azure Monitor logs. You will also learn about managing applications using Azure Monitor Application Insights. Going further, you will learn how to respond to critical situations by enabling Azure Monitor alerts. You will also learn to configure diagnostic settings in the Azure portal while understanding the uses of diagnostic logs. Each week has its share of hands-on practice exercises that break the monotony of theoretical concepts. In week 1, you will explore Azure Monitor and practice enabling log analytics. Using Azure Monitor, you will also practice collecting virtual machine or VM event and performance data. Transitioning into the second week, you will learn about enabling and managing Microsoft Defender for Cloud, a unified cloud-native application protection platform that helps strengthen your security posture. You will learn to implement Microsoft Defender for Cloud, protect all your resources under one roof, and track your security progress. You will also learn to customize various global Microsoft Defender for Cloud options. You will be introduced to Microsoft Defender for Servers and learn to apply Azure security baselines to servers. During the week, you will learn to manage and implement Microsoft Defender for Cloud recommendations and monitor your security status with Microsoft Defender for Cloud recommendations. You will learn about brute force attacks and how just-in-time virtual machine or JIT VM access can protect against brute force attacks. You will also learn to configure malware detection. In week 2, you will practice implementing Microsoft Defender for Cloud. You will also configure Microsoft Defender for Cloud policies. Further, you will practice enabling JIT VM access for Azure VMs in the subscription. Let's explore what's in store in week 3. This week, you will be introduced to Microsoft Sentinel, a scalable cloud-native solution that provides security information and event management, or SIEM, and security orchestration, automation, and response, or SOAR. You will learn to enable Microsoft Sentinel and configure data connections to Microsoft Sentinel. That's not all. You will learn to create Azure Monitor workbooks and use them to visualize and monitor Microsoft Sentinel data. After connecting your data sources to Microsoft Sentinel, You will learn to create custom analytics rules to help discover threats and anomalous behaviors in your environment. You will learn to turn on health monitoring for Microsoft Sentinel. You will also learn to create watch lists that allow you to correlate data from a data source you provide with events in your Microsoft Sentinel environment. Bet you are waiting to know what you will put into practice this week. You will practice connecting Microsoft Defender for cloud alerts to Microsoft Sentinel. You will also use playbooks with automation rules in Microsoft Sentinel. In addition, you will investigate threats. Now on to fourth week, the last week of this course, which promises to be the most engaging. In this week, you will have the opportunity to step into the role of an Azure security engineer and solve a fascinating real-life case study where you will make critical decisions to manage security operations. This project will test your ability to apply most of the knowledge and skills you gained in this course. To refresh your knowledge, the course summary will serve as a comprehensive recap, highlighting the important concepts you learned in this course. After completing the hands-on course project, you will tackle a course-level graded assessment designed to mimic the format of the AZ-500 exam. All set to further explore these topics? Delve into the remaining readings and videos in this course and fast-track your progress toward becoming a Microsoft Azure Security Engineer Associate.
Your organization neglected to monitor its Azure resources after migration. This oversight led to security breaches, compromising sensitive data and causing reputational damage. Additionally, performance issues went unnoticed, resulting in frequent downtime and dissatisfied customers. How could the organization have proactively detected threats, optimized performance, and prevented these detrimental outcomes? Hello, and welcome to the video, What is Azure Monitor? In this video, you'll be introduced to Azure Monitor and how it enables security monitoring within the Azure environment. You'll also learn about the need for implementing security controls and audits, and leveraging the capabilities of Microsoft Defender for cloud. Before we dive into what the Azure Monitor is, let's explore the concept of monitoring. In the Azure environment, monitoring refers to collecting insights about your resources' operation, performance, and behavior. Monitoring also involves actively detecting potential security issues and promptly responding to them. There are two main detection approaches, reactive and proactive. Reactive detection involves responding to suspicious activity alerts and quickly responding to mitigate the issue. On the other hand, proactive detection involves actively hunting for anomalous events in the activity logs of Azure resources and uncovering potential threats before they cause significant damage. So what is Azure Monitor? Azure Monitor is a comprehensive monitoring solution for collecting, analyzing, and responding to telemetry data from your cloud and on-premises environments. You can use Azure Monitor to maximize the availability and performance of your applications and services. Azure Monitor actively watches over the performance of all your Azure resources and promptly triggers alerts when an issue arises. So, why is it crucial to monitor your resources? Monitoring and updating your systems is as important as your initial secure setup. It's crucial to monitor your resources as it helps maintain a strong security posture and identify vulnerabilities. Next, let's look at how you can manage Azure's security operations using Azure Monitor. Monitoring security using Azure Monitor involves 3 steps: creating and customizing alerts, monitoring security logs, and configuring diagnostic logging and log retention. To prevent security assurance decay, it's essential that you vigilantly respond to anomalies and alerts. In addition, it's also important to adopt the defense in-depth strategy and the principle of least privilege. In the ever-evolving landscape of cybersecurity, organizations must maintain effective security controls against attackers who are constantly refining their tactics and attacking digital assets. The key will be to use the principle of continuous improvement to ensure your systems are regularly evaluated and updated. Your initial focus should be to remediate common security risks that are usually from well-established attack vectors. This move will force infiltrators to acquire more advanced and expensive attack methods, increasing the barriers to successful attacks. Let's look at a few recommendations to ensure a robust security posture. 1. Document the processes for handling incidents and post-incident activities, such as lessons learned and evidence retention. 2. Remediate common risks identified by Microsoft Defender for Cloud. 3. Track remediation progress using secure scores and historical comparisons. And 4. Address alerts and take necessary action through remediation steps. However, to ensure your security posture doesn't degrade over time, you must conduct regular internal and external compliance audits. It's also crucial to enable, acquire, and store audit logs for Azure services. Here are a few key points to consider when conducting an audit. Improve secure scores in Microsoft Defender for Cloud. Evaluate your organization's security posture against industry standard benchmarks. Review policy requirements. And utilize Azure Governance Visualizer for a comprehensive overview of Azure Governance implementation. Most cloud architectures comprise compute, networking, data, and identity components, each requiring specific monitoring mechanisms. Similarly, Azure services also have unique monitoring needs. For example, you'll have to enable Azure Application Insights to monitor Azure functions. You can leverage Microsoft Defender for Cloud to monitor the security posture of your resources and identify potential security issues. Common issues include Internet-connected virtual machines, or VMs, missing security updates, missing endpoint protection or encryption, deviations from baseline security configurations, and missing web application firewall, or WAF. Before we conclude, let's look at a few recommendations to secure your organization's digital assets. 1. Implement Microsoft Defender for Cloud as a defense in-depth measure and utilize resource-specific features, such as Microsoft Defender for Servers, Microsoft Defender for Endpoint, and Microsoft Defender for Storage. 2. Maintain container hygiene by using container-aware tools and ensuring regular scanning. 3. Evaluate all network flow logs via Azure Network Watcher and access diagnostic logs in Microsoft Defender for Cloud. 4. Integrate all logs into a centralized security information and event management, or SIEM solution, for analysis and detection of suspicious behavior. And finally, monitor identity-related risk events by leveraging Azure Active Directory or Azure AD reports and Azure AD Identity Protection. With that, let's summarize the key takeaways. In this video, you learned about Azure Monitor and how it enables security monitoring within the Azure environment. You also learned the importance of improving security controls, conducting regular audits, and implementing effective monitoring mechanisms to enhance your organization's security posture. In addition, you learned to leverage the capabilities of Microsoft Defender for Cloud to identify and mitigate potential security risks. An e-commerce firm's website caters to a large volume of customers daily. Recently, they've been facing frequent outages and slow response times. The existing monitoring tools do not provide sufficient insights, and the organization lacks visibility into its Azure resources. This inadequacy impedes its ability to understand the underlying issues and take proactive measures. How can the organization improve its monitoring capabilities? Hello, and welcome to the video Explore Azure Monitor. In this video, you'll learn about the two fundamental data types that Azure Monitor uses. You'll learn to stream collected monitor data to external security information and event management, or SIEM tools, via Microsoft Defender for Cloud. In addition, you'll learn about the data tiers that can be sent to Azure Event Hubs. You'll also learn to connect to Microsoft Sentinel. Let's start with a diagram depicting the two fundamental data types Azure Monitor uses, metrics and logs. Now, how are these data types populated? Monitoring data sources such as applications, operating systems, Azure resources, Azure subscriptions, Azure tenants, and other custom sources populate these data types. There are different functions that Azure Monitor will perform with this collected data, including generating insights, visualization, analysis, response, integration, and streaming to external systems. For most Azure resources, you'll find the data that Azure Monitor collects in the Monitoring tab of the Resources Overview page. For example, in a virtual machine or VM, you'll notice several charts displaying the VM's performance metrics. Selecting any chart will open the data in Metrics, where you can chart the values of multiple metrics over time. You can view the charts interactively or save them to a dashboard. You can also analyze the log data that Azure Monitor collects using Kusto Query Language, or KQL. With KQL, you can create and test queries to analyze the log. These queries can then be saved and utilized for visualizations or alert rules, providing valuable insights into your data. Next, let's look at how you can stream the collected monitor data to external SIEM tools via Microsoft Defender for Cloud. Microsoft Defender for Cloud integrates with Azure Monitor to provide centralized logging and monitoring capabilities. The processed events generated by Microsoft Defender for Cloud are published to the activity log, one of the log types available through Azure Monitor. Azure Monitor provides a centralized pipeline for routing monitor data to a SIEM tool by first streaming that monitoring data to Azure Event Hubs, from where it can easily be transferred to a partner's SIEM tool. The Azure Monitor single pipeline provides access to monitoring data from your Azure environment, including the security data generated by Microsoft Defender for Cloud. This pipeline lets you easily set up SIEM and other monitoring tools to consume that data effectively. The security data exposed from Microsoft Defender for Cloud to a SIEM tool consists of alerts containing information about detected threats, suspicious activities, and other security-related events within your cloud environment. Microsoft Defender for Cloud then automatically collects, analyzes, and integrates log data from your Azure resources, the network, and connected partner solutions to detect real threats and reduce false positives. It displays prioritized security alerts, the information needed to investigate the problem, and recommendations for attack remediation. Recall that Azure Event Hubs is used to stream log data from Azure Monitor to partner SIEM tools, monitoring tools, or Microsoft Sentinel. So, what is Azure Event Hubs? Azure Event Hubs is a streaming platform and event ingestion service that can transform and store data using any real-time analytics provider or batching or storage adapters. Let's look at how you can configure data to be streamed to Azure Event Hubs, assuming you already have Microsoft Defender for Cloud configured in your Azure subscription. There are 5 tiers of monitoring data within your Azure environment, and the method of collecting data from each tier varies slightly. The 5 tiers of monitoring data are Application Monitoring Data, Guest Operating System or Guest OS Monitoring Data, Azure Resource Monitoring Data, Azure Subscription Monitoring Data, and Azure Tenant Monitoring Data. Let's look at each of them in detail. Application monitoring data includes data about the performance and functionality of the code you have written and are running on Azure. Some examples of application monitoring data include performance traces, application logs, and user telemetry. Application monitoring data is usually collected in one of the following ways: by instrumenting your code with a software development kit, or SDK, such as the Azure Monitor Application Insights SDK, or by running a monitoring agent that listens for new application logs on the VM running your application, such as the Windows Azure Diagnostic Agent or the Linux Azure Diagnostic Agent. Guest OS monitoring data includes data about the OS on which your application is running. Some examples are Linux, syslog, and Windows system events. You'll need to install an agent such as the Windows Azure Diagnostic Agent or the Linux Azure Diagnostic Agent to collect guest OS monitoring data. Next, moving to the Azure Resource Monitoring Data, this tier includes data about the operation of the Azure resource. Some Azure resource types, such as VMs, have a guest OS and applications to monitor that Azure resource. The resource monitoring data is the highest tier available for other Azure resources, such as network security groups, since no guest OS or applications monitor these resources. Azure Resource Monitoring data can be collected using resource diagnostic settings. Azure Subscription Monitoring data includes data about the operation and management of an Azure subscription, as well as data about Azure's health and operation. The Azure Monitor Activity Log contains subscription monitoring data, such as service health incidents and Azure Resource Manager audits. You can collect Azure Subscription Monitoring data using a log profile. Azure Tenant Monitoring data covers data related to the operation of tenant-level Azure services, such as Azure Active Directory, commonly referred to as Azure AD. Some examples of tenant monitoring data are Azure AD audits and sign-ins. This type of data can be collected using a tenant diagnostic setting. So, can data from any tier be sent to event hubs? Yes. Data from any tier can be sent to event hubs, from where it can be pulled to a SIEM tool. While some sources can be configured to send data directly to event hubs, another service, like Azure Logic Apps, may be required to retrieve the required data. Next, we'll look at connecting data sources to Microsoft Sentinel. With Microsoft Sentinel, enterprises worldwide can keep pace with the exponential growth in security data, improve security outcomes without adding analyst resources, and reduce hardware and operational costs. To onboard Microsoft Sentinel, you must first enable Microsoft Sentinel and then connect your data sources. Microsoft Sentinel offers a range of connectors for seamless integration with Microsoft solutions. You can also use common event formats like syslog or Representational State Transfer API, commonly called REST API, to connect your data sources with Microsoft Sentinel. After you connect your data sources, choose from a gallery of expertly created dashboards that surface insights based on your data. Let's summarize. In this video, you learned about the two fundamental data types that Azure Monitor uses, metrics and logs. You learned to stream collected monitor data to external SIEM tools via Microsoft Defender for Cloud. Then, you learned about the 5 tiers of monitoring data that can be sent to Azure Event Hubs. Finally, you learned how you can connect data sources to Microsoft Sentinel.
As a security engineer at an organization migrating all its systems to Microsoft Azure, you have been tasked with ensuring a comprehensive monitoring strategy. The management stresses the importance of proactive monitoring and wants to adopt an approach covering all application and infrastructure layers. You are diligently evaluating your options and considering the most suitable monitoring approach. Hello, and welcome to the video Introduction to Full Stack Monitoring in Azure. In this video, you will learn about the need for full stack monitoring. You will also learn why you should monitor your applications, infrastructure, and Azure platform resources. In addition, you will be introduced to security monitoring. Let's get started. Full stack monitoring is a comprehensive approach for monitoring, triaging, and diagnosing applications, infrastructure, and security issues. It involves the collection of telemetry data, tracking of key performance indicators, and the capability to isolate problems and perform root cause analysis. During operations, your applications and infrastructure may encounter various issues, such as sluggish response times, fluctuating usage rates, and security risks. When faced with such issues, your response must be targeted at the root cause of the problem. For instance, if you are experiencing increased load, scaling up capacity to accommodate higher demand might be necessary. Similarly, optimizing performance and reducing errors may involve adjusting your application's configuration, code, or sometimes even the underlying infrastructure. Implementing a full-stack monitoring approach for your applications and infrastructure enables you to respond to changes and issues appropriately and on time. This proactive approach will ensure performance optimization. Also, over time, it will foster increased productivity, cost efficiency, security, and a competitive advantage for your organization. Next, let's understand why you must monitor your applications, infrastructure, and Azure platform resources. We'll begin with applications. The objective of any organization would be to improve the health and performance of its existing applications, while also striving to build better applications in the future. To achieve this goal, you must implement robust alert configurations and automated response mechanisms that enable efficient issue resolution and application management. So there are 2 phases of monitoring an application: when it's being developed, 2, when it is live and in use. By monitoring your application for issues as it's being developed, you'll prevent errors and exceptions when your application goes into production. You'll ensure your code only gets pushed to the next stage of the development cycle if it has successfully passed all necessary checks. The result? You enhance the overall development lifecycle, ensure reliability, and minimize potential issues. On the other hand, it is also crucial that you monitor your live application in real time. As depicted in these charts, your application might face various issues when it's live. The issues could range from failing requests and prolonged server response times to sometimes even complete unavailability of the application. However, you can effectively identify and promptly address these issues through comprehensive monitoring, ensuring optimal performance. Next, let's look at the importance of monitoring your infrastructure. Various issues can impact your infrastructure as well. You may encounter performance issues or problems that could render your services inaccessible or your entire infrastructure unavailable. These issues can result in decreased productivity, financial losses, or harm to your organization's reputation. You'll want to deal with all such issues swiftly. An ideal way will be to configure alerts on your infrastructure to monitor various issues. For example, you could configure alerts for resource utilization of the infrastructure, availability and health of the infrastructure, or occurrence of a specific event at the operating system or OS level. How will these alerts help? These alerts will be vital in initiating a process where you receive timely notifications, triage issues, and then take appropriate actions. You can also leverage playbooks and webhooks to trigger automated responses to alerts. You must also utilize the collected data for operational analysis and capacity planning. For example, as shown here, you can collect performance data such as CPU utilization, available memory, and so on from guest operating systems or virtual machines or VMs. You can then organize this data into charts, compare the data, analyze trends, and make informed decisions to secure your infrastructure. In addition to monitoring your deployed applications and infrastructure resources, you must leverage Azure's built-in capabilities to monitor your Azure platform resources. Azure resources such as storage accounts, key vaults, and Cosmos DB are equipped with performance metrics and resource logs that you can view and analyze to track performance and availability. Further, several Azure resources have dedicated insights that offer predefined monitoring experiences across multiple subscriptions, resource groups, and resource types. For example, the Azure Monitor Storage Insight displays usage and latency for multiple storage accounts across 2 subscriptions. You can also view and collect logs related to Active Directory for your Azure tenant and service health and activity for your Azure subscriptions. That brings us to why full-stack monitoring is so important. A full-stack monitoring or solution provides visibility into Azure platform resources that form the foundation of your applications and infrastructure. We discussed performance and availability monitoring in detail. Now let's discuss an equally important subject: monitoring the security of our applications and infrastructure so they always remain protected and available. For example, you should actively monitor and set up alerts for potential security risks to your infrastructure, such as suspicious user accounts or malicious IP addresses, and data exfiltration attempts or unauthorized access to sensitive information. One thing to remember when considering a security monitoring solution is that it should incorporate advanced and automated anomaly detection and event management capabilities to consolidate multiple related events into a single actionable alert. Why? Because that will help you streamline incident response and effectively mitigate potential security breaches. Finally, let's sum up the benefits of full-stack monitoring. Adopting a full-stack approach to monitor your applications and infrastructure will empower you to respond promptly and appropriately to issues. It will also enhance your situational awareness and help you gather valuable insights from the incidents impacting your Azure environment. As a result, you can maintain a strong and proactive security posture that ensures your system's ongoing protection, availability, and reliability. Let's recap the key takeaways. In this course, you learn that full-stack monitoring is a comprehensive approach for monitoring, triaging, and diagnosing applications, infrastructure, and security issues. You also learn that you should monitor your applications, infrastructure, and Azure platform resources to strengthen your organization's security posture and build improved applications and infrastructure. In addition, you learn the importance of monitoring the security of your applications and infrastructure to ensure they always remain protected and available.
Hello, and welcome to the video, Configure and Monitor Metrics and Logs. In this video, you'll learn about the types of metrics supported by Azure Monitor metrics and the sources from which Azure Monitor collects metrics. You'll be introduced to the Metrics Explorer and learn how to use logs in Azure Monitor. In addition, you'll explore the security tools to monitor logs. Let's get started. All the data that Azure Monitor collects fits into one of two fundamental data types, metrics or logs. Azure Monitor Metrics is a feature of Azure Monitor that collects numeric data from monitored resources into a time series database. Metrics are numerical values collected at regular intervals to describe various system aspects at a particular time. Azure Monitor Logs is a feature of Azure Monitor that collects and organizes log and performance data from monitored resources. A log message refers to a system-generated set of data that describes an event that has occurred. A log message comprises log data, including information about the event, such as the resource accessed, the user or entity who accessed it, the time of the event, and so on. Each system event can have different datasets within the log message. While logs are about a specific event, metrics are the values collected at a specific point in time to describe various system aspects. Logs may be collected during an event, but metrics are typically collected at fixed intervals. Let's discuss the data types in detail. Azure Monitor supports multiple types of metrics for monitoring and analysis. Native metrics in Azure Monitor are designed to be used with the built-in analysis and alerting capabilities provided by Azure Monitor. Platform metrics are a subset of native metrics automatically collected from Azure resources. They are pre-configured. So, there's no additional configuration required and no cost is incurred. Custom metrics are collected from various sources that you configure, such as applications and agents running on virtual machines or VMs. You can leverage custom metrics to go beyond the default Azure Monitor metrics and gather insights into specific aspects of your applications. Prometheus metrics, preview, are collected from Kubernetes clusters, including Azure Kubernetes Service or AKS. Prometheus metrics use industry-standard tools like Prometheus Query Language or PromQL, and Grafana for analysis and alerting. So what are Prometheus, PromQL, and Grafana? Prometheus is an open-source toolkit that collects data for monitoring and alerting purposes, while PromQL is the flexible query language used in Prometheus to retrieve and analyze collected data. Azure-managed Grafana is a data visualization platform built on top of the open-sourced Grafana software by Grafana Labs. It's a fully managed Azure service operated and supported by Microsoft. Grafana helps combine metrics, logs, and traces into a single user interface. Azure Monitor collects metrics from various sources and consolidates them in the metric database, while they're evaluated together regardless of their source. The sources include Azure resources, applications, VM agents, custom metrics, and Kubernetes clusters. Let's explore these sources. Azure resources. Platform metrics generated by Azure resources offer insights into their health and performance. Each resource type has its own distinct set of metrics collected at a 1-minute frequency, unless otherwise specified in the metrics definition. Application Insights generates metrics for your monitored applications, helping detect performance issues and track usage trends. Examples of values include server response time and browser exceptions. VM agents. Metrics are collected from the guest operating system, or guest OS, of VMs. You can enable guest OS metrics for Windows VMs using the Windows Diagnostic extension and for Linux VMs using the Influx Data Telegraph agent. You can define custom metrics for your applications monitored by Application Insights. Additionally, you can create custom metrics for Azure services using the Custom Metrics API. Kubernetes clusters typically send metric data to a local Prometheus server that requires maintenance. Azure Monitor offers a managed service for Prometheus that collects metrics from Kubernetes clusters and stores them in Azure Monitor metrics. So, how can you analyze the data collected in the metric database? You can use Metrics Explorer to interactively analyze the data in your metric database and chart the values of multiple metrics over time. You can also pin these charts to a dashboard to view them alongside other visualizations for comprehensive monitoring. You can retrieve metrics using the Azure Monitor Representational State Transfer API or REST API. Next, let's delve into Azure Monitor logs. In logging systems, a common type of log entry is an event. Events are generated sporadically by applications or services and contain sufficient information to provide complete context. So, what do they capture? Events capture significant occurrences such as creating or modifying a resource, starting a new host in response to increased traffic, or detecting an error in an application. Events are flexible in terms of data format. Hence, applications can create custom logs based on their specific requirements. Metric data can even be stored within logs to combine them with other monitoring data, enabling trend analysis and other forms of data analysis. You can use logs in Azure Monitor to analyze, visualize, alert, retrieve, and export data. Let's see how. To analyze log data, use Log Analytics in the Azure portal to write log queries and interactively analyze log data using the Data Explorer Analysis Engine. Similarly, use the Application Insights Analytics console to write log queries and interactively analyze log data from Application Insights. To aid visualization, pin query results rendered as tables or charts to an Azure dashboard. Create workbooks to combine multiple datasets in interactive reports. Export query results to Power BI for different visualizations and to share them with users outside of Azure. And export query results to Grafana to leverage its dashboarding capabilities and combine them with other data sources. Next, let's understand how you can use logs to create alerts. Configure log alert rules that trigger notifications or automated actions when query results match specified conditions. You can also set up metric alert rules based on log data extracted as metrics. To retrieve data, access log query results from the command line using Azure Command Line Interface, CLI, or PowerShell commandlets. Alternatively, retrieve log query results from a custom application using REST API. To export log data, build workflows to retrieve log data and copy it to an external location using Logic Apps. Data in Azure Monitor logs is retrieved using a log query written with Kusto Query Language or KQL, which allows quick retrieval, consolidation, and analysis of collected data. You can use Log Analytics in the Azure portal to write and test log queries, as it provides an interactive environment where you can work with query results and pin them to a dashboard for combined visualization. Security tools such as Microsoft Defender for Cloud and Azure Sentinel provide powerful capabilities to monitor logs. Microsoft Defender for Cloud collects data and stores it in a log analytics workspace where it can be analyzed with other log data. On the other hand, Azure Sentinel utilizes a log analytics workspace to store data from various sources. It's time to recap. In this video, you learned about the types of metrics supported by Azure Monitor metrics and the sources from which Azure Monitor collects metrics. You were introduced to Metrics Explorer and learned how to use logs in Azure Monitor. In addition, you explored the security tools to monitor logs. The security team of a large financial organization detected unusual network activity indicative of a security breach. Despite deploying various security measures, they've been unable to determine the origin of the breach. Should the organization leverage Azure Log Analytics for comprehensive log analysis and real-time threat detection? Will that help identify the breach's origin and safeguard critical assets? Hello, and welcome to the video, Enable Log Analytics. In this video, you'll learn about the functionality of log analytics. You'll explore the different ways to access log analytics within the Azure portal and learn about the practical applications of log queries. You'll also be introduced to the Log Analytics workspace. So, what is log analytics? Log Analytics is a part of Microsoft Azure's overall monitoring solution. It helps you monitor your cloud and on-premises environments to ensure continuous availability and optimal performance. Log Analytics is the primary tool in the Azure portal for writing log queries and interactively analyzing the outcomes. Even if a log query is employed elsewhere in Azure Monitor, it's recommended that you first write and test the query using Log Analytics. How can you access Log Analytics? You can access log analytics from two locations within the Azure portal. Select Logs from the Azure Monitor menu or Log Analytics Workspaces menu. Or select Logs from the menu of any Azure resource, for example, a virtual machine. However, note that the access method determines the scope of data available to log analytics. In addition to conducting interactive log query analysis within log analytics, queries are extensively utilized in various areas of Azure Monitor. The areas include alert rules, dashboards, views, export, PowerShell, and Azure Monitor Logs API. Let's look at these areas in detail. Alert rules proactively identify issues by performing log searches on the data in your workspace. Alert rules automatically run log searches at regular intervals, and the results are inspected to determine if an alert should be triggered. Dashboards allows you to pin any queries results on the Azure dashboard, enabling the visualization of log and metric data together. You can also share these dashboards with other Azure users. Next, we'll look at views. You can create visual representations of the data to be included in user dashboards using workbooks. Log queries provide the necessary data for tiles and visualization components within each view. Export. When importing log data from Azure Monitor into Excel or Power BI, you create a log query to define the data to be exported. You typically incorporate the results of a log query into a PowerShell script from a command line or an Azure Automation runbook. The Azure Monitor Logs API allows any representational state transfer API or REST API client to retrieve log data from the workspace. API requests involve querying Azure Monitor to specify the data that needs to be retrieved. Moving forward, let's discuss Log Analytics Workspaces. Log Analytics Workspaces hosted within the Azure environment are the core component of Log Analytics. Log Analytics collects data from connected sources within these workspaces by configuring data sources and adding solutions to your subscription. Each data source and solution contributes distinct record types with their unique properties. However, despite this diversity, Log Analytics allows you to analyze sources and solutions together via queries to the workspace. This capability allows you to use the same tools and methods to work with a wide range of data collected from diverse sources, ensuring efficient and unified data analysis. You can use the Log Analytics Workspaces menu to create a Log Analytics workspace in the Azure portal. The Log Analytics Workspace is a unique environment for managing Azure Monitor log data. Each workspace has a dedicated data repository and data sources, and solutions are configured to store their data in a specified workspace. So, when is it necessary to create a Log Analytics Workspace? You require a Log Analytics Workspace if you want to collect data from the following sources: Azure resources in your subscription, on-premises computers monitored by Microsoft System Center Operations Manager, or SCOM, device collections from Microsoft System Center Configuration Manager, or diagnostics or log data from Azure Storage. Let's summarize. In this video, you learned about the functionality of Log Analytics. You explored the various Log Analytics access points within the Azure portal and learned about the practical applications of log queries. You were also introduced to the Log Analytics Workspace. An effective monitoring solution must proactively respond to critical situations identified in the data it collects. This could be sending a text or mail to an administrator responsible for investigating an issue. Or you could launch an automated process that attempts to correct an error condition. Hello, and welcome to the video, Responding to Critical Situations. In this video, you will learn about the different alert rules for a response, common alert schemas, and how alert processing rules allow you to apply processing on fired alerts. Let's begin by looking at the alert rules for response. An alert rule monitors your data and captures a signal that indicates something is happening on the specified resource. The alert rule captures the signal and checks to see if the signal meets the criteria of the condition. If the conditions are met, an alert is triggered, which initiates the associated action group and updates the state of the alert. An alert rule combines the resources to be monitored, the signal or data from the resource, and the conditions. If you're monitoring more than one resource, the condition is evaluated separately for each resource. Alerts are fired for each resource separately. Here are some related concepts you need to know about. Action groups can trigger notifications or an automated workflow to inform users that an alert has been triggered. Action groups can include notification methods such as email, SMS, and push notifications, automation runbooks, Azure functions, IT service management or ITSM incidents, logic apps, secure webhooks, and event hubs. Alert conditions refer to conditions set by the system. When an alert fires, the alert's monitor condition is set to fired. After the underlying condition that caused the alert to fire clears, the monitor condition is set to resolved. User response is the response the user sets and doesn't change until the user changes it. Alert processing rules can be used to modify triggered alerts as they're being fired. You can use alert processing rules to add or suppress action groups, apply filters, or process the rule on a predefined schedule. Next, let's explore the common alert schema. Historically, activity log, metric, and log alerts had their own email templates and webhook schemas. The common alert schema standardizes the consumption of Azure Monitor alert notifications. It provides one standardized schema for all alert notifications. Using a standardized schema helps minimize the number of integrations, simplifying managing and maintaining your integrations. The common schema enables a richer alert consumption experienced in the Azure portal and mobile app. The common alert schema provides a consistent structure for email templates. You can use the detailed email template to diagnose issues at a glance. Embedded links to the alert instance on the portal and the affected resource ensure you can quickly jump into the remediation process. JSON structure. You can use the consistent JSON structure to build integrations for all alert types using Azure Logic Apps, Azure Functions, and Azure Automation Runbook. Finally, let's look at alert processing rules. Alert processing rules allow you to apply processing to fired alerts. Alert processing rules are different from alert rules. Alert rules generate new alerts, while alert processing rules modify the fired alerts as they're fired. You can use alert processing rules to add action groups or remove, that is, suppress action groups from your fired alerts. You can apply alert processing rules to different resource scopes, from a single resource to an entire subscription. You can also use them to apply various filters or have the rule work on a predefined schedule. Exploring some common use cases for alert processing rules will be helpful. The first is when you need to suppress notifications during planned maintenance. Many customers set up planned maintenance time for their resources on a one-time or regular schedule. The planned maintenance might cover a single resource, like a virtual machine or VM, or multiple resources, like all VMs in a resource group. So you might want to stop receiving alert notifications for those resources during the maintenance window. In other cases, you might prefer not to receive alert notifications outside business hours. Alert processing rules allow you to achieve that. You could suppress alert notifications by turning off the alert rules themselves at the beginning of the maintenance window and re-enabling them after maintenance. In that case, the alerts won't fire in the first place. That approach has several limitations. This approach is only practical if the scope of the alert rule is precisely the scope of the resources under maintenance. For example, a single alert rule might cover multiple resources, but only a few are going through maintenance. So if you turn off the alert rule, you won't be alerted when the remaining resources covered by that rule run into issues. You might have many alert rules that cover the resource. Updating all of them is time-consuming and error-prone. You might have some alerts not created by an alert rule, like Azure Backup Alerts. An alert processing rule provides an easy way to suppress notifications in all these cases. The second is when you need management at scale. Most customers tend to define a few action groups that are used repeatedly in their alert rules. For example, they might want to call a specific action group whenever a high-severity alert is fired. As their number of alert rules grows, manually making sure each alert rule has the right set of action groups becomes harder. Alert processing rules allow you to specify that logic in a single rule instead of consistently setting it in all your alert rules. They also cover alert types that aren't generated by an alert rule. Time to recap. In this video, you learned how alert rules work for responding to critical situations, the key concepts related to alert rules, how common alert schema standardizes the consumption of Azure Monitor alert notifications, and how alert processing rules allow you to apply processing on fired alert. So much of our daily living is organized with the help of alerts. They draw our attention to systems that require observation, inspection, and intervention. Whether it is a notification at work to submit your timesheet, your car telling you the fuel tank needs refilling, or even a weather alert for heavy rains. Similarly, in Microsoft Azure, alerts help you detect and address issues before users notice them. Alerts proactively notify you when Azure Monitor data indicates a problem with your infrastructure or application. Azure Monitor has metrics, logging, and analytics features. Another useful feature is Monitor Alerts. Hello, and welcome to the video, Enable Azure Monitor Alerts. In this video, you will learn how Azure Monitor Alerts work to notify you of critical situations and take suitable action. In addition to allowing you to analyze monitoring data interactively, an effective monitoring solution must proactively respond to critical conditions identified in the data it collects. This could be sending a text or mail to an administrator responsible for investigating an issue, or you could launch an automated process that attempts to correct an error condition. Azure Monitor Alerts proactively notify you of critical conditions and potentially attempt to take corrective action. Alert rules based on metrics provide near real-time alerting based on numeric values, while rules based on logs allow for complex logic across data from multiple sources. Alert rules in Azure Monitor use action groups containing unique sets of recipients and actions that can be shared across multiple rules. Based on your requirements, action groups can perform such actions as using webhooks to have alerts start external actions or to integrate with your IT service management, also known as ITSM tools. The unified alert experience in Azure Monitor includes alerts that log analytics and application insights previously managed. In the past, Azure Monitor, Application Insights, Log Analytics, and Service Health had separate alerting capabilities. Over time, Azure improved and combined both the UI and different methods of alerting. The consolidation is still in process. Next, let's look at an overview of alerts in Azure. This diagram represents the flow of alerts. Alert rules are separated from alerts and the actions taken when an alert fires. The alert rule captures the target and criteria for alerting. The alert rule can be in an enabled or disabled state. Alerts only fire when enabled. Here, you can see the key attributes of an alert rule. A target resource defines the scope and signals available for alerting. A target can be any Azure resource. Example targets include a virtual machine or VM, a storage account, a VM scale set, a log analytics workspace, or an application insights resource. For certain resources, like VMs, you can specify multiple resources as the target of the alert rule. A signal is emitted by the target resource. Signals can be of the following types: metric, activity log, application insights, and log. Criteria refer to a combination of signals and logic applied to a target resource. For example, the percentage of the CPU should be greater than 70%. Server response time should be more than 4 milliseconds. The result count of the log query should be greater than 100. An alert name is a specific name for the alert rule configured by the user. An alert description is a description of the user's alert rule. Severity refers to the alert severity after the criteria specified in the alert rule are met. Severity can range from 0 to 4, where severity 0 is critical. Severity 1 refers to an error. Severity 2 is a warning. Severity 3 is informational. And Severity 4 is verbose. Action refers to a specific action taken when the alert is fired. Next, let's look at what you can alert on. You can alert on metrics and logs. These include, but are not limited to, metric values, log search queries, activity log events, the health of the underlying Azure platform, tests for website availability. With the consolidation of alerting services still in process, Some alerting capabilities are not yet in the new alert system, as shown here. These include activity logs, which are used to view and create activity log alerts on service notifications, and web availability tests, which view web test alerts. They are available to any website that's instrumental to send data to application insights. A notification is received when the availability or responsiveness of a website is below expectations. Let's recap. In this video, you learned how Azure Monitor alerts proactively notify you of critical conditions and attempt to take corrective action, the flow of alerts, the key attributes of alert rules, what you can alert on, alerting capabilities yet to be included in the new alert system. As IT administrators, it is essential to monitor utilization and understand where and how resources deployed are being used and what they are costing the organization. To facilitate this, you can use certain tools built in Microsoft Azure. Diagnostic logging, which is captured at the resource level, is one such tool that allows you to view detailed logs. Hello, and welcome to the video, Configure Properties for Diagnostic Logging. In this video, you will learn about the types of diagnostic logs, how to configure diagnostic settings in Azure Portal, and what diagnostic logs are used for. Azure Monitor diagnostic logs are logs produced by an Azure service that provide rich, frequently collated data about the operation of that service. Azure Monitor makes two types of diagnostic logs available. Tenant logs. These logs come from tenant-level services that exist outside of an Azure subscription, such as Azure Active Directory, also called Azure AD. Resource logs. These logs come from Azure services that deploy resources within an Azure subscription, such as network security groups, frequently called NSGs, or storage accounts. The content of these logs varies by Azure service and resource type. For example, NSG rule counters and Azure Key Vault audits are two types of diagnostic logs. These logs differ from the activity log. The activity log provides insight into the operations, such as creating a virtual machine, also called a VM, or deleting a logic app, that Azure Resource Manager performed on resources in your subscription. The activity log is a subscription-level log. Resource-level diagnostic logs provide insight into operations performed within that resource, such as getting a secret from a key vault. These logs differ from guest operating systems or OS-level diagnostic logs. Guest OS diagnostic logs are those collected by an agent running inside a VM or other supported resource type. They capture data from the OS and applications running on a VM. Resource-level diagnostic logs, on the other hand, require no agent and capture resource-specific data from the Azure platform itself. Next, you will see how to create diagnostic settings in the Azure portal. You can configure diagnostic settings in the Azure portal either from the Azure Monitor menu or from the menu for the resource as shown here. Do you know that diagnostic logs have several uses? Here are some of the things you can do with diagnostic logs. You can save them to storage account for auditing or manual inspection. You can specify the retention time in days by using resource diagnostic settings. You can stream them to event hubs for ingestion by a third-party service or custom analytics solution, such as Power BI. You can analyze them with Azure Monitor such that the data is immediately written to Azure Monitor without needing to first write the data to storage. Streaming of diagnostic logs can be enabled programmatically via the portal or using the Azure Monitor Representational State Transfer, or REST APIs. Either way, you create a diagnostic setting that specifies an Azure Event Hub's namespace and the log categories and metrics you want to send into the namespace. An Event Hub is created for each log you enable in the namespace. A diagnostic log category is a type of log that a resource may collect. Time to recap. In this video, you learned the types of diagnostic logs Azure Monitor makes, how to create diagnostic settings in the Azure portal, and the different uses for diagnostic logs. Congratulations! You've completed learning about the Azure Monitor, configuring and monitoring metrics and logs, and enabling Azure Monitor alerts. Let's recap what you've learned. Initially, you were introduced to Azure Monitor, a comprehensive monitoring solution for collecting, analyzing, and responding to telemetry data from your cloud and on-premises environments. You learned the importance of improving security controls, conducting regular audits, and implementing effective monitoring mechanisms to enhance your organization's security posture. You went on to learn about the two fundamental data types Azure Monitor uses: metrics and logs. Metrics are numerical values describing some aspect of a system at a point in time, and logs contain time-stamped information about resource changes. You learned that Microsoft Defender for Cloud integrates with Azure Monitor to provide centralized logging and monitoring capabilities. You were also introduced to the 5 tiers of monitoring data that can be sent to Azure Event Hubs: application monitoring data, guest operating system or guest OS monitoring data, Azure resource monitoring data, Azure subscription monitoring data, and Azure tenant monitoring data. Azure Event Hubs streams log data from Azure Monitor to partners' security information and event management, SIEM tools, monitoring tools, or Microsoft Sentinel. Next, you delve deeper into the monitoring solutions available in Azure: Azure Monitor, Microsoft Defender for Cloud, and Microsoft Sentinel. Azure Monitor collects and analyzes telemetry data, offering insights, visualizations, and alerting capabilities for applications, infrastructure, and platforms. Microsoft Defender for Cloud centrally manages security across on-premises and cloud workloads, providing tools to enhance defense against threats. And Microsoft Sentinel is a scalable, cloud-native SIEM and security orchestration, automation, and response (SOAR) solution that collects data from various sources, detects threats, and enables proactive hunting and automated responses. You also learned that these monitoring solutions leverage log analytics workspaces, which serve as a centralized storage location for applications, infrastructure, and security logs. Then, you learned about the features of Azure Monitor logs, including analyzing logs using the Kusto query language, KQL. Your learning wasn't limited to theoretical concepts. You actively reinforced your knowledge through hands-on exercises, where you explored Azure Monitor to monitor the availability, performance, and operation of critical applications that rely on Azure resources. Progressing further, you learned about full-stack monitoring in Azure, a comprehensive approach for monitoring, triaging, and diagnosing applications, infrastructure, and security issues. In addition to monitoring your deployed applications and infrastructure resources, you learned that you must leverage Azure's built-in capabilities to monitor your Azure platform resources. Azure resources, such as storage accounts, key vaults, and Cosmos DB, are equipped with performance metrics and resource logs that you can view and analyze to track performance and availability. Then you learned about the types of metrics supported by Azure Monitor metrics: native metrics, the subsets of native metrics, platform metrics and custom metrics, and Prometheus metrics. Preview. Next, you learn that you can use Azure Monitor Application Insights to analyze and address issues that affect your application's health and performance, improve your application's development lifecycle, and measure user experience and analyze user behavior. You also learn to integrate Azure Monitor Application Insights with your applications to monitor performance and availability. Then, you acquired knowledge about log analytics, a part of Microsoft Azure's overall monitoring solution that helps you monitor your cloud and on-premises environments to ensure continuous availability and optimal performance. You were also introduced to Log Analytics Workspaces. Hosted within the Azure environment, Log Analytics Workspaces are the core component of Log Analytics. Log Analytics collects data from connected sources within these workspaces by configuring data sources and adding solutions to your subscription. Once again, you had the opportunity of a hands-on exercise where you practice configuring log analytics and running a query. You then learn to write Azure Monitor log queries using log analytics. You can use KQL to query log information for your services running in Azure. A Kusto query is a read-only request to process data and return results. Next, you learn to monitor the health and performance of your virtual machines, VMs, and VMs at scale using Azure Monitor VM Insights. You also learn to monitor the health and performance of your Kubernetes workloads at scale using Azure Monitor Container Insights. Moving forward, You discovered how alert rules respond to critical situations. You learned that an alert rule combines the resources to be monitored, the signal or data from the resource, and the conditions. If you're monitoring more than one resource, the condition is evaluated separately for each resource, and alerts are fired separately. You also learned that alert processing rules, which differ from alert rules, allow you to apply processing to fired alerts. Alert rules generate new alerts, while alert processing rules modify fired alerts as they're fired. In addition to allowing you to analyze monitoring data interactively, an effective monitoring solution must proactively respond to critical conditions identified in the data it collects. You learned that Azure Monitor alerts proactively notify you of critical conditions and take corrective actions. Alert rules based on metrics provide near real-time alerting based on numerical values, while alert rules based on logs allow for complex logic across data from multiple sources. Next, you were introduced to the flow of alerts in Azure. Alert rules are separated from alerts and the actions taken when an alert fires. The alert rule captures the target and the criteria for alerting and can be in an enabled or disabled state. Alerts only fire when enabled. Moving on, you learned that Azure Monitor makes two diagnostic logs available: tenant and resource logs. Tenant logs come from tenant-level services outside an Azure subscription, such as Azure AD. Resource logs come from Azure services that deploy resources within an Azure subscription, such as network security groups, frequently called NSGs, or storage accounts. You are presented with another opportunity to engage in a hands-on exercise. This time, you practice collecting data from an Azure VM using Azure Monitor. Phew! Wasn't that an exceptional learning experience? You're now fully prepared to advance to the next stage and confidently tackle the graded assessment for this module. Good luck with the module quiz.
As a security engineer responsible for safeguarding an organization's digital assets, you rely on Microsoft Defender for Cloud to effectively track, maintain, and enhance overall security. Your role involves tackling various tasks contributing to a robust security posture, including implementing the recommended security measures suggested by Microsoft Defender for Cloud. Additionally, you diligently review and promptly respond to the secure score evaluations to ensure optimal protection against potential threats. Leveraging the comprehensive capabilities of Microsoft Defender for Cloud, you actively employ preventive measures to thwart any potential attacks and uphold the organization's security standards. Hello, and welcome to the video. Recap: what is Microsoft Defender for Cloud? In this video, you'll recall how Microsoft Defender for Cloud is your central location for setting and monitoring the organization's security posture. You'll also know about solutions that adhere to security measures and systems that need to be secured. Microsoft Defender for Cloud is a cloud-native application protection platform, or CNAPP, with a set of security measures and practices designed to protect cloud-based applications from various cyber threats and vulnerabilities. So, Development Security Operations, or DevSecOps solution, brings security management into your code, whether you're working across different clouds or multiple pipelines. Then we have a handy Cloud Security Posture Management, or CSPM solution that helps you keep your cloud security in check. It's like having a watchful eye that shows actionable steps you can take to prevent any potential breaches. And let's not forget about the Cloud Workload Protection Platform, or CWPP, that's specifically designed to safeguard your servers, containers, storage, databases, and other workloads. It's like having a personal bodyguard for your digital assets, ensuring everything stays protected. With Defender for Cloud, you can easily adopt strong security practices right from the start of software development, embracing the concepts of DevSecOps. It enables you to safeguard your code management environments and code pipelines while gaining valuable insights into the security posture of your development environment, all from one convenient place. To further enhance DevOps security across multiple pipelines, Defender for DevOps, a service within Defender for Cloud, empowers security teams with comprehensive management capabilities. This is crucial today, where applications need code, infrastructure, and runtime protection, ensuring robust defense against potential attacks. Code pipeline insights are a game changer for security teams, protecting applications and resources from code to the cloud. It seamlessly integrates with Defender for DevOps, leveraging findings to prioritize remediation in your code. Connect Azure DevOps and GitHub to Defender for Cloud for a secure code pipeline. Explore Microsoft Azure's website for Defender plan details and pricing options. Your cloud and on-premises resources security hinges on how well they are configured and deployed. When it comes to safeguarding your environment, the recommendations provided by Defender for Cloud are invaluable. They outline the steps you can take to ensure the security of your setup. The best part is that Defender for Cloud offers foundational CSPM capabilities at no cost. And if you want to go the extra mile, you can activate the advanced CSPM capabilities by enabling the Defender CSPM plan. Centralized policy management allows you to define and maintain security conditions across your environment. It provides recommendations based on your security policy, including the Microsoft Cloud Security Benchmark. Get started by customizing your security policy and enjoy foundational CSPM capabilities for free with the Defender plan. Ever wondered how secure your system is? With the Secure Score capability, you can easily gauge your security posture by summarizing the recommended security measures. As you remediate these recommendations, your Secure Score improves, indicating enhanced security. Ready to track your Secure Score and boost your system's protection? It's time to get started. And the good news is that you can access the foundational CSPM capabilities for free with the Defender plan. With the multi-cloud coverage capability, you can effortlessly connect to your various multi-cloud environments. This feature provides agentless methods for gaining insight into your cloud security posture, or CSPM, and ensuring comprehensive workload protection, or CWP. Connect your Amazon Web Services, or AWS, and Google Cloud Platform, or GCP, cloud resources to Defend for Cloud and enjoy seamless security management. You can access the foundational CSPM capabilities for free with the Defender plan. So why wait? Start securing your multi-cloud environment today. When it comes to proactive security, it's crucial to implement practices that safeguard your workload against potential threats. That's where CWP comes in. They provide tailored recommendations for securing your specific workloads, guiding you toward the right security controls. In the event of a threat to your environment, timely security alerts are generated to inform you about the nature and severity of the situation. This allows you to plan your response accordingly. Once you've identified a threat, it's important to swiftly take action to minimize the risk to your resources. A quick response is key to maintaining a secure environment. Protect Cloud Servers is a capability that solves the problem of ensuring server security by offering multiple layers of protection. You can leverage Microsoft Defender for Endpoint or opt for extended protection, including just-in-time network access, file integrity monitoring, vulnerability assessment, and more. Identify threats to your storage resources is a powerful capability that helps you identify threats targeting your storage resources. It solves the problem of detecting abnormal and potentially harmful activities, providing contextual security alerts by leveraging advanced threat detection capabilities and Microsoft Threat Intelligence data. Protect Cloud Databases is a powerful capability designed to protect your cloud databases. It solves the problem of safeguarding your entire database estate by offering attack detection and threat response specifically tailored for popular database types in Azure. This ensures the protection of database engines and data types based on their attack surface and security risks. Protect Containers is a powerful capability designed to protect your containers. It solves the problem of ensuring the security of your clusters, containers, and applications. You can improve, monitor, and maintain container security with features like environment hardening, vulnerability assessments, and runtime protection. Infrastructure Service Insights is a powerful capability that helps you address a specific problem. It allows you to diagnose vulnerabilities in your application infrastructure that could make your environment vulnerable to attacks. Security Alerts is a capability that aims to solve a specific problem. It keeps you informed about real-time events that pose a threat to the security of your environment. These alerts are carefully categorized and assign severity levels, helping you understand the appropriate response needed. Security Incidents is a capability that aims to solve a specific problem. It enables you to correlate alerts and uncover attack patterns. You can also integrate it seamlessly with Security Information and Event Management, also known as SIEM, Security Orchestration Automated Response, also known as SOAR, and IT Service Management, also known as ITSM solutions. This empowers you to respond effectively to threats and minimize the risk to your valuable resources. Now let's summarize the key points. Microsoft Defender for Cloud is your all-in-one solution for securing cloud applications. It combines multiple security measures, promotes DevSecOps, and protects servers, containers, storage, and databases. With insights into infrastructure services, real-time security alerts, and incident management capabilities, it ensures comprehensive protection. Additionally, you can access foundational CSPM features for free or explore advanced options with the Defender plan. Stay ahead of cyber threats and keep your cloud environment secure. As a security engineer, Emily tirelessly reviews the cyber kill chain, analyzing attack vectors and identifying vulnerabilities within a large organization's network. With her expertise and a vigilant eye, Emily works diligently to fortify defenses and protect the company's digital assets. Hello, and welcome to the video. Review the cyber kill chain. In this video, we'll delve into the stages of the cyber kill chain, uncovering strategies to detect, prevent, and mitigate cyber threats effectively. Since the birth of the internet, cyber attacks have been a persistent threat. Recently, a new breed of intrusions called Advanced Persistent Threats, also known as APTs, has emerged, posing a significant challenge to traditional defense mechanisms. While traditional defenses can fend off known intrusions, they fall short against APTs. That's why it's crucial to develop intrusion detection methods that continuously monitor networks and security controls for their effectiveness. Although models like anomaly-based and signature-based detection have been used, their success has been limited. Adversaries quickly learn the actions and signatures that trigger these models, allowing them to evade detection. In contrast, the kill chain has proven more effective in identifying intrusions. Developed by Lockheed Martin, the cyber kill chain framework is part of the intelligence-driven defense model for identifying and preventing cyber intrusions activity. The model identifies what the adversaries must complete to achieve their objective. The kill chain model is an intrusion detection approach driven by intelligence consisting of 7 distinct phases. These phases improve intrusions' visibility and enable security teams to gain insights into an adversary's tactics, techniques, and procedures. By diving into the underlying process of intrusions, this intelligence-driven model reveals the nature of the intrusions and provides insights into the motives behind them. Together, these phases form a cohesive end-to-end process represented as a chain where disrupting any step can disrupt the entire sequence. The figure illustrates this concept, showcasing how an adversary progresses through various phases to achieve their objectives. In a typical Advanced Persistent Threat, or APT, 7 phases are involved: reconnaissance, weaponization, delivery, exploitation, installation, command and control, or C2, and actions on objectives. During the reconnaissance phase, attackers gather intelligence by harvesting email addresses and gathering conference information. They aim to gather as much data as possible about potential targets and their vulnerabilities before proceeding further in the intrusion process. In the weaponization phase, attackers take their exploits further by coupling them with a backdoor, creating a deliverable payload. This payload is carefully crafted to exploit vulnerabilities and provide the attacker with a secret entry point into the target system. In the delivery phase, attackers employ various methods to deliver the weaponized bundle to their intended victim. This can be done through email attachments, malicious websites, or USB drives. The goal is to trick or entice the victim into opening the weaponized bundle, unknowingly granting access to their system. During exploitation, attackers exploit the victim's system vulnerabilities to execute malicious code. By exploiting these weaknesses, adversaries gain control over the victim's system and can execute commands or run their own code. This phase is critical for attackers as it allows them to establish a foothold and further their intrusion objectives. In the installation phase, attackers install malware on the target asset. This malicious software is designed to perform unauthorized activities and give the attacker control or access to the compromised system. By successfully installing the malware, adversaries establish a persistent presence, allowing them to carry out their intended actions such as stealing data, monitoring activities, or launching further attacks. In the command and control C2 phase, attackers establish a command channel as a remote control center for manipulating the victims. This channel allows adversaries to send instructions and commands to the compromised system, enabling them to remotely control and manipulate it according to their malicious objectives. With this control level, attackers can execute actions, extract data, or launch further attacks without physical access to the victim's device or network. In the actions on objectives phase, attackers with hands-on keyboard access work diligently to achieve their initial goals. Having gained control and established a strong presence within the compromised system, adversaries can now carry out their intended actions. This could involve various activities such as exfiltrating sensitive data, modifying or deleting files, disrupting services, or launching additional attacks. Now let's summarize the key points. We explored the stages of the cyber kill chain and discovered effective strategies to detect intrusions. We also learned about light advanced persistent threats, APTs, challenges to traditional defense methods. Also, we know that the kill chain excels at identifying intrusions and why continuous monitoring is crucial. From gathering intelligence to achieving objectives, we learned about each phase of the kill chain. Sarah is a diligent IT professional responsible for managing the cloud infrastructure of a large multinational corporation. As she navigates the complex world of cloud computing, Sarah is keenly aware of the critical need for strong security measures. That's when she discovers Microsoft Defender for Cloud, an innovative solution that aims to strengthen her organization's cloud security posture and protect its workloads against ever-evolving threats. Excited by its potential, Sarah dives headfirst into implementing this cutting-edge solution, confident that it will elevate her organization's security resilience to new heights. Hello, and welcome to the video, Implement Microsoft Defender for Cloud. In this video, you will learn how you can strengthen your cloud security with Microsoft Defender for Cloud, an all-encompassing solution to safeguard your digital environment against evolving threats. Microsoft Defender for Cloud is a comprehensive solution that brings together DevOps security management, streamlining the process and ensuring a more secure environment for your operations. It strengthens cloud security posture management, frequently referred to as CSPM. It finds weak spots across your cloud configuration and helps strengthen the overall security posture of your environment. It is also a solution for cloud workload protection, frequently referred to as CWP. It protects workloads across multi-cloud and hybrid environments from evolving threats. Defender for Cloud fills three vital needs as you manage the security of your resources and workloads in the cloud and on-premises. Firstly, Defender for Cloud Secure Score continually assesses your security posture so you can track new security opportunities and precisely report on the progress of your security efforts. Next, Defender for Cloud Recommendations secures your workloads with step-by-step actions that protect your workloads from known security risks. Lastly, Defender for Cloud Alerts defends your workloads in real time, so you can react immediately and prevent security events from developing. Defender for Cloud also helps boost the security of your cloud resources to ensure they're well protected. It helps you keep a constant check on the security of your cloud resources in Azure. You can also take advantage of predefined policies and recommendations that follow important industry and regulatory standards. Or if you prefer, you can create your own custom requirements that fit your organization's specific needs. With Microsoft Defender for Cloud, you have a powerful tool at your disposal to tackle those ever-changing threats in multi-cloud and hybrid environments. And the best part? You can manage everything from a single convenient location. With plenty of automation options, you'll be able to streamline your security administration effortlessly without juggling multiple tools. In cases where it's required, Defender for Cloud can effortlessly deploy a log analytics agent to gather crucial security-related data. The deployment process is seamless for Azure machines as it is handled directly. For hybrid and multi-cloud environments, the power of Microsoft Defender extends to non-Azure machines through the assistance of Azure Arc. This means you can enjoy the robust features of Cloud Security Posture Management, CSPM, across multi-cloud machines without the hassle of installing any agents. Looking to safeguard your Azure native resources, Defender for Cloud is here to lend a hand by enabling you to identify and combat threats across multiple fronts. Let's explore how this powerful tool can enhance your security posture and protect valuable assets. Azure Platform as a Service, or PaaS, services detects and responds to threats targeting Azure services, such as Azure App Service, Azure SQL, Azure Storage Account, and more. Additionally, you can also leverage the native integration with Microsoft Defender for Cloud Apps, formerly known as Microsoft Cloud App Security, to perform anomaly detection on Azure activity logs. Azure Data Services. With Defender for Cloud, you can automatically classify your data in Azure SQL and receive assessments for potential vulnerabilities in Azure SQL and storage services. It also provides recommendations on how to effectively mitigate these vulnerabilities. Networks enhances your network security by countering brute force attacks. Defender for Cloud enables you to reduce access to virtual machine ports and implement just-in-time VM access, fortifying your network against unnecessary entry. Take advantage of secure access policies that restrict access to authorized users, specific source IP address ranges, or IP addresses and for a limited time. Alongside protecting your Azure environment, you have the option to fortify your hybrid cloud setup by incorporating Defender for Cloud capabilities, ensuring the security of your non-Azure servers. Tailored threat intelligence and prioritized alerts are provided, allowing you to concentrate on the most critical aspects of your environment. To extend protection to on-premises machines, simply deploy Azure Arc and activate Defender for Cloud's advanced security features. With Defender for Cloud's CSPM features, your AWS resources can be assessed without the need for an agent. This assessment follows AWS-specific security recommendations and contributes to your overall secure score. Moreover, your resources will be checked for compliance with AWS Center for Internet Security, or CIS, AWS Payment Card Industry, or PCI, Data Security Standards, or DSS, and AWS foundational security best practices. To make things even better, Defender for Cloud's asset inventory page allows you to manage your AWS resources alongside your Azure resources, providing a convenient multi-cloud solution. Ensure you're not leaving any vulnerabilities exposed to potential attacks. Defender for Cloud has you covered with built-in vulnerability assessment solutions for virtual machines, container registries, and SQL servers. The scanners, including those powered by Qualys, seamlessly integrate into Defender for Cloud, so you don't need an extra license or account. Microsoft Defender for Servers also integrates with Microsoft Defender for Endpoint, giving you comprehensive vulnerability findings from Microsoft Defender Vulnerability Management. You can conveniently review and respond to all these findings within Defender for Cloud, making it your go-to platform for all your cloud security needs. Keeping your workload secure requires tailored security policies, and Defender for Cloud has got you covered. With policies built on top of Azure Policy Controls, you have the flexibility of a top-notch policy solution. Set policies to run on management groups, subscriptions, or even the entire tenant. Defender for Cloud continuously discovers and assesses newly deployed resources across your workloads. If any resources don't meet security best practices, they're flagged, and you receive a prioritized list of recommendations to address the issues. These recommendations help you minimize the attack surface for each resource. The list of recommendations is backed by the Microsoft Cloud Security Benchmark, which offers guidelines based on common compliance frameworks. Originally designed for Azure, this benchmark now provides best practices for security and compliance across multiple cloud environments. In essence, Defender for Cloud empowers you to establish and enforce secure configuration standards across all your resources, going beyond just setting security policies. Take your Defender for Cloud protection to the next level with the advanced threat protection features. They safeguard your virtual machines, SQL databases, containers, web applications, and network. You can also secure your VM's management ports with just-in-time access, adding an extra layer of defense. Additionally, you can utilize adaptive application controls to create allow lists, giving you control over which apps can run on your machines and enhancing security. Microsoft Defender for Cloud offers a range of comprehensive defenses across your environment, covering compute, data, and service layers. The defenses are as listed here: Microsoft Defender for Servers, Microsoft Defender for Storage, Microsoft Defender for Structured Query Language or SQL, Microsoft Defender for Containers, Microsoft Defender for App Service, Microsoft Defender for Key Vault, Microsoft Defender for Resource Manager, Microsoft Defender for Domain Name System or DNS, Microsoft Defender for Open Source Relational Databases, Microsoft Defender for Azure Cosmos Database or DB. Defender CSPM is your comprehensive solution for security governance and regulatory compliance. With Cloud Security Explorer, gain a deep understanding of your cloud environment security status. Perform attack path analysis to identify potential vulnerabilities. Benefit from agentless scanning for machines, ensuring efficient security assessment. And don't forget about Defender for DevOps, empowering you with robust security throughout your development lifecycle. Defender Cloud Security Posture Management is your trusted partner in safeguarding your cloud infrastructure. Keep an eye on the Workload Protection's Azure dashboard, where you can monitor and configure each advanced protection features. Just a quick tip, Microsoft Defender for the Internet of Things, or IoT, is a standalone product, separate from the others. When Defender for Cloud detects a threat, it generates a security alert that provides details of affected resources, recommended remediation steps, and the option to trigger a logic app if needed. You can export these alerts to Microsoft Sentinel, third-party security information, and event management SIEMs or other external tools. Defender for Cloud's threat protection includes Fusion kill chain analysis, correlating alerts based on cyber kill chain analysis for a comprehensive view of attack campaigns. Supported kill chain intents are based on the MITRE attack matrix. Let us recap. Microsoft Defender for Cloud is a go-to solution for boosting cloud security. It scans your cloud setup, finds and addresses vulnerabilities, and keeps your workload safe in multi-cloud and hybrid environments. It offers ongoing security assessment, gives step-by-step recommendations to protect your workloads, and alerts you in real time to prevent security issues from escalating. Plus, it ensures the security of your cloud resources in Azure, AWS, and Google Cloud, whether you choose predefined policies or tailor them to your specific needs. With valuable insights and streamlined administration, you can manage everything from a single, convenient location. In today's cloud-centric environment, centralized policy management is crucial for maintaining robust security. With Microsoft Defender for Cloud, organizations can enforce tailored security policies, monitor compliance, and ensure adherence to regulatory requirements, all while streamlining operations and protecting sensitive data. Hello, and welcome to the video, Centralized Policy Management with Microsoft Defender for Cloud. In this video, you'll learn about the significance of centralized policy management. You'll also discover how organizations can leverage Microsoft Defender for Cloud in enabling comprehensive policy enforcement, compliance monitoring, and data protection. With Azure Policy, you have the flexibility to define specific requirements for your Azure subscriptions, tailoring them to match your workload type or the sensitivity of your data. Discover how Azure Policy empowers you to enforce well-designed policies, optimize operations, and ensure robust security for your organization. With complete integration into Azure Policy, Microsoft Defender for Cloud monitors policy compliance across your subscriptions. It uses default security policies that recommend controls for resources within subscriptions or resource groups. These policies define workload configurations and ensure compliance with company and regulatory security requirements. You can customize these defaults to align with your organization's unique needs. Defender for Cloud can monitor policy compliance across your subscriptions using a default set of security policies. Some key policies include enabling secure transfer to storage accounts, provisioning an Azure Active Directory or Azure AD Administrator for SQL Server, utilizing Azure Active Directory for client authentication. By default, Microsoft Defender for Cloud activates all security policies for every monitored subscription. These policies and recommendations are interconnected, enabling a security policy such as operating systems, also called OS vulnerabilities, to trigger corresponding recommendations. With Defender for Cloud, you have the flexibility to define policies tailored to your Azure subscriptions or resource groups based on your company's specific security requirements and the nature of applications or sensitivity of data within each subscription. This approach ensures a streamlined and customized security framework. So let's say you have different resources for development or testing compared to what you use for production applications. Well, it's quite possible that these resources would have different security requirements. Also, another thing to consider, if you're dealing with regulated data such as personal information, you might need an even higher level of security. Policies are inherited from the subscription down to the resource groups. However, you can control the security policies individually at the resource group level. It's important to note here that if you want to tweak those security policies at either the subscription or resource group level, you need to have the owner or resource policy contributor permissions for that subscription. When working with security policies, a helpful way to get started is by checking out the active security policies. You can view the active security policies through the Defender for Cloud environment settings. After selecting your subscription, select Security Policy to see the default or custom initiatives enabled on your subscription. In this case, we'll select the default initiative. Select the Parameters tab and you'll see a list of policy parameters with drop-down menus. You might need to uncheck the Only Show Parameters checkbox to see an unfiltered view. From the list of policy parameters, search for System Updates and then select System Updates should be installed on your machines. From the drop-down, select Audit if not exists. In this subscription, when Enhanced Security is turned off, every virtual machine or VM will go through an audit to ensure it has installed the latest security updates. If any VM fails this check, don't worry, it'll generate an audit event to let you know, so you can stay on top of any update-related issues and keep your VMs updated. You can modify policies for Azure subscriptions and management groups using Azure Portal, Azure PowerShell, and Azure Command Line Interface, also known as Azure CLI or the REST API. Let's recap. We explored how Microsoft Defender for Cloud simplifies policy management, enforcing custom security rules, and monitoring compliance. Azure Policy ensures strong security for Azure subscriptions, allowing tailored requirements. With the integration between Microsoft Defender for Cloud and Azure Policy, policy compliance is monitored and personalized security recommendations are provided. The tool actively monitors key security policies, enhancing overall security by focusing on secure transfer, Azure AD administration, and system updates.
Rachel, an IT professional, often finds herself contemplating the best strategy to reinforce their defenses against evolving threats. Armed with her expertise and the robust capabilities of the solution, she envisions a shield that safeguards servers irrespective of their location. Azure, Amazon Web Services, also known as AWS, Google Cloud Platform, also known as GCP, or on-premises environments. With eager anticipation, Rachel deep dives into Microsoft Defender for Servers, eager to explore its endpoint detection and response, also known as EDR capabilities, and its array of protective features. Hello, and welcome to the video overview of Microsoft Defender for Servers. In this video, you will acquire an overview of Microsoft Defender for Servers. You will also explore how Defender for Servers offers robust protection for Windows and Linux servers across diverse environments. You'll also be able to design and plan an effective Defender for Servers deployment. If you're wondering how to make the most of Defender for Servers, this video is here to help. It will walk you through designing and planning a super effective deployment strategy. And guess what? Microsoft Defender for Cloud has got you covered with 2 paid plans for Defender for Servers, so you can choose the one that suits your needs best. Defender for Servers is mainly something that catches the attention of cloud solution and infrastructure architects, security architects, and analysts, and basically anyone who is into safeguarding cloud and hybrid servers and workloads. Let us deep dive into some key questions about Defender for Servers. To start with, what exactly does Defender for Servers do, and how do you go about deploying it? Curious about where your data is stored and which log analytics workspaces are necessary? We'll cover that too. Who should have access to your Defender for Servers resources? We'll help you figure it out. Choosing the right Defender for Servers plan and vulnerability assessment solution can be daunting. We'll guide you through the decision-making process. Wondering when to use Azure Arc and which agents and extensions are needed? We've got you covered. And of course, scaling a deployment is crucial. We'll show you how to do it effectively. When it comes to deploying Defender for Servers, it is helpful to have an overview of the process. Here's a breakdown of the stages involved in deploying Defender for Servers along with their details. The first stage is start protecting resources. When you open Defender for Cloud in the portal, it immediately starts protecting resources by conducting free foundational cloud security posture management, also known as CSPM assessments, and providing recommendations. Defender for Cloud creates a default log analytics workspace with the Security Center free solution enabled. Recommendations will start appearing in the portal to help you enhance your security. The second stage is enabling Defender for Servers. So here's how it works when you upgrade to a paid plan with Defender for Cloud. Once you've selected either Plan 1 or Plan 2, the security solution will be automatically enabled on the default workspace. Now, after you have enabled the plan, you will need to choose how you want to install agents and extensions on your Azure VMs within the subscription or workgroup. By default, auto-provisioning is enabled for certain extensions, making the process smoother. The third stage is to protect AWS GCP machines. When it comes to deploying Defender for Servers, there are a few steps you will need to follow to ensure the protection of your Amazon AWS or GCP machines. First, you'll set up a connector and turn off plans you don't need. Then, configure the auto-provisioning settings. This is important because it includes all the agents required by Defender for Cloud, as well as the Azure Connected Machine agent for onboarding to Azure using Azure Arc. For AWS deployments, you will utilize a CloudFormation template, while for GCP deployments, a Cloud Shell template will be used. These templates make the deployment process more streamlined and efficient. Once you have completed the deployment, it's important to monitor the recommendations that will appear in the portal. These recommendations will provide valuable insights and suggestions to further enhance the security of your system. The fourth stage is protect on-premises servers. When it comes to safeguarding your on-premises servers, you will need to follow a couple of steps to ensure their protection. The first step is to onboard these servers as Azure Arc machines, which allows you to manage them through Azure services. Once the servers are onboarded, the next step is to deploy the required agents using automation provisioning. This process automates the deployment of necessary agents, ensuring that your servers are equipped with the right tools to enhance their security. The last or the fifth stage is foundational CSPM. Let's delve into the details of the foundational CSPM that brings essential security capabilities without any additional charges, making it a valuable asset. For AWS and GCP machines, you can benefit from foundational CSPM right away without the need for Azure Arc setup. However, when it comes to on-premises machines, you will need to configure Azure Arc to leverage the foundational CSPM. When you activate Microsoft Defender for Servers on your Azure subscription or connected AWS account, all the machines linked to it receive comprehensive protection. It is important to note that Microsoft Defender for Servers operates at the log analytics workspace level. This means that only the servers reporting to that specific workspace will be safeguarded and built accordingly. However, it's worth mentioning that by confining the protection to a particular workspace, some additional benefits may not be available for those servers. These include features like Microsoft Defender for Endpoint, vulnerability assessment, and just-in-time VM access. So it's essential to consider the trade-offs when making decisions regarding the scope of protection for your servers. Let's recap. In this video, you explored how Microsoft Defender for Servers offers comprehensive protection for both Windows and Linux servers. You also learned about the stages involved in the successful deployment of an efficient Defender for Servers solution.
Meet Alex, a skilled cybersecurity analyst at a renowned financial institution, is assigned with the critical task of configuring Defender for cloud policies. Alex tirelessly works to strengthen the organization's defenses. With a vigilant eye for potential threats and a knack for policy customization, Alex aims to safeguard sensitive financial data from cybercriminals and maintain regulatory compliance. Hello, and welcome to the video, Configure Defender for Cloud Policies. In this video, you'll learn how to effectively set up and customize Defender for Cloud policies to enhance your organization's defense against cyber threats. When it comes to protecting your subscriptions, Microsoft Defender for Cloud has got your back. It applies security initiatives that consist of various security policies. Each policy gives you recommendations to enhance your security posture. Let's dive in and explore how it all works. Consider a security initiative as an asset in your cybersecurity toolkit. It functions like a coordinated team of Azure policy definitions and rules, collaborating to achieve a shared objective. Grouping these policies streamlines their administration, treating them as a unified entity. This simplification not only eases your workload, but also reinforces your security measures for maximum effectiveness. Just as security policies, Defender for Cloud initiatives is also built and created in Azure Policy. They facilitate streamlined policy management. With Azure Policy, you have the power to manage your policies, create initiatives, and assign them to multiple subscriptions or even entire management groups. When you set up Microsoft Defender for Cloud, every subscription comes with a special treat: the default initiative known as the Microsoft Cloud Security Benchmark. This benchmark is a comprehensive guide developed by Microsoft, incorporating top-notch security and compliance best practices from trusted sources such as the Center for Internet Security, also known as CIS, and the National Institute of Standards and Technology, also known as NIST. It's designed to prioritize cloud-centric security and keep your systems fortified. When it comes to working with security initiatives and policies in Defender for Cloud, you have some handy options. You can view and edit the built-in default initiative. When you activate Defender for Cloud, the Microsoft Cloud Security Benchmark initiative is automatically assigned to all registered subscriptions. But don't worry, you can tweak it to fit your needs. Simply edit the parameters of individual policies within the initiative to enable or disable them. It's all about tailoring your security to match your requirements. You can add your own custom initiatives. If you prefer to personalize the security initiatives applied to your subscription, simply dive into Defender for Cloud and start crafting your own initiatives. As a bonus, you'll receive helpful recommendations whenever your machines don't align with the policies you've created. You can also add regulatory compliance standards as initiatives. Get a bird's-eye view of your regulatory compliance with Defender for Cloud's Regulatory Compliance Dashboard. This feature presents the status of assessments within your environment, all in the context of specific standards or regulations, whether it's Azure CIS, NIST, SP 853 Revision 4, CSP, CSCF v 2020. You'll have all the insights on compliance. An Azure Policy definition, which you can create in Azure Policy, is basically a rule that helps you control specific security conditions. It allows you to set guidelines for things like the types of resources that can be deployed or ensuring all resources have the necessary tags. Azure Policy provides some pre-built definitions for common scenarios, but you can also create your own custom policy definitions to fit your specific needs. To put these policy definitions into action, whether they're built-in or custom ones, you'll need to assign them. Assigning policies can be done using the Azure Portal, PowerShell, or Azure Command Line interface, also known as Azure CLI, so you have different options to choose from. Once assigned, you have the flexibility to enable or disable these policies directly from Azure Policy. giving you control over their enforcement. In Azure Policy, you'll come across different types of policies. When it comes to Defender for Cloud, it primarily relies on audit policies. These policies are designed to examine specific conditions and configurations, providing compliance reports based on the findings. On the other hand, there are enforce policies that serve a different purpose. They allow you to enforce security settings, ensuring that the desired security measures are applied. So, depending on your needs, you have the option to leverage either audit policies for assessment or enforce policies for enforcing security settings. So, here's a recap of what we've learned. Microsoft Defender for Cloud is there to keep your subscription safe and protect important data with its security initiatives and policies. With Azure Policy, you have the power to manage and customize those security initiatives, including the default Microsoft Cloud Security Benchmark. Azure Policy also offers pre-built and custom policy definitions that you can assign and enforce to control security conditions and make sure you're complying with regulations. It's all about keeping your system secure and in line with the necessary standards. As the newly appointed security manager, you've been tasked with managing and implementing the comprehensive Defender for Cloud recommendations at ABC Corporation. With cyber threats on the rise, your expertise is crucial in fortifying the organization's infrastructure. Your role involves coordinating with cross-functional teams, assessing vulnerabilities, and executing robust security measures to safeguard sensitive data and ensure business continuity. Success will require a proactive approach and close collaboration with stakeholders across the company. Hello, and welcome to the video, Manage and Implement Microsoft Defender for Cloud Recommendations. In this video, you'll learn how to effectively manage and implement Defender for Cloud recommendations to enhance your organization's cybersecurity. You'll gain valuable insights into key strategies and best practices to safeguard sensitive data and mitigate cyber threats. Let's dive in. With the help of policies, Defender for Cloud keeps an eye on your resources' compliance status. It looks out for any security misconfigurations or weaknesses and gives you recommendations on how to fix them. It does this by assessing your resources against the policies and flagging any that don't meet your requirements. Defender for Cloud tailors its security recommendations to align with your chosen initiatives. If a policy from your initiative identifies non-compliant resources during evaluation, it promptly presents those as recommendations within the tool. When it comes to securing and strengthening your resources, recommendations are your go-to actions. They guide you on what steps to take. Each recommendation packs useful details such as a quick issue description, step-by-step remediation instructions, and a list of affected resources. So always remember this: initiatives encompass policies that generate environment-specific recommendations. Security recommendations are more than just suggestions. They provide you with vital details that not only highlight the significance of the issue at hand, but also offer guidance on how to address and resolve it effectively. Let's explore how these recommendations can empower you to enhance your security measures. When it comes to support recommendations, the top toolbar provides you with some handy buttons. You'll find options like Exempt and Disable Rule, allowing you to take immediate action. Need more context? Just click on View the Policy Definition to jump directly to the Azure Policy entry. And if you want detailed information about the affected resources, the Open Query option lets you explore them using Azure Resource Graph Explorer. It's all about giving you easy access and control over your security measures. Additionally, to further aid your understanding of the security recommendations, there's a severity indicator. This indicator helps you assess the importance and urgency of each recommendation, enabling you to prioritize your actions accordingly. Furthermore, there's a freshness interval associated with the security recommendations. This interval indicates the time frame within which the recommendations are updated and reflects the most recent assessment of your resources. Keeping an eye on the freshness interval ensures you have the latest insights and can proactively address any emerging security concerns. When it comes to Azure scored recommendations, you'll find a useful feature called Tactics and Techniques. If a recommendation has defined tactics and techniques, simply select the icon and it'll provide you with convenient links to the relevant pages on MITRE's site. This way you can gain valuable insights and understand the broader context of the recommendation within the MITRE attack framework. It's an excellent resource for enhancing your security knowledge and aligning your defense strategies. In each security recommendation, you'll find a description that gives you a quick overview of the identified security issue. This description provides you with a concise summary of what the problem is, allowing you to grasp the key details briefly. It serves as a valuable starting point for understanding the nature and urgency of the security concern. On the details page of a recommendation, you may come across a table of related recommendations that provide additional insights. These related recommendations can be of three types: prerequisite, alternative, or dependent. They help you understand the relationships between recommendations and their interdependencies. You'll also find the number of unhealthy resources associated with each related recommendation in the affected resources column. Remember, if a related recommendation appears grayed out, it means its dependency hasn't been completed or is currently unavailable. Keep this tip in mind while exploring the related recommendations. Within the security recommendation, you'll find the remediation steps section, which provides a clear description of the manual actions required to address the identified security issue on the affected resources. For recommendations that offer a fix option, you can review the remediation logic by selecting View Remediation Logic before applying the suggested fix to your resources. This allows you to have a better understanding of the changes being made and make informed decisions when implementing the fix. To help you manage your resources effectively, the affected resources are organized into different tabs. Let's look at each one. Unhealthy Resources tab lists resources that are still affected by the identified issue and require attention. Healthy Resources tab. Here you'll find relevant resources that are either not impacted by the identified issue or have already been remediated. Not Applicable Resources tab. For resources that the recommendation can't provide a definitive answer for, you'll find them in this tab. It also includes reasons explaining why the recommendation doesn't apply to each specific resource. This ensures you have a clear understanding of the status of all your resources. To take action and address the security recommendation, you'll find convenient buttons at your disposal. These buttons allow you to initiate the remediation process or trigger a logic app, depending on the nature of the recommendation. With just a click, you can actively work toward resolving the identified security issue and strengthening your overall security posture. These action buttons provide you with a straightforward and efficient way to remediate the recommendations. As we discussed earlier, the built-in recommendations in Defender for Cloud are rooted in the Microsoft Cloud Security Benchmark. This means that nearly every recommendation is backed by an underlying policy, which is directly linked to a specific requirement within the benchmark. This alignment ensures that the recommendations provided by Defender for Cloud are closely aligned with industry best practices and Microsoft's comprehensive security standards. When you're exploring the details of a recommendation, it can be quite beneficial to have access to the underlying policy. That's why, for each recommendation that is supported by a policy, you'll find a handy View Policy Definition link right on the recommendation details page. By clicking this link, you can instantly navigate to the Azure policy entries specifically related to the policy associated with the recommendation. This direct access allows you to delve deeper into the policy details and gain a comprehensive understanding of the security measures in place. If you're going through the Security Recommendations Reference Guide, you'll find links to the policy definition pages there as well. Refer to the policy to know the definition and check out the evaluation logic. Let's recap. It's vital to implement strong security measures to safeguard sensitive data and maintain uninterrupted business operations. The Security Recommendations Reference Guide offers valuable insights and strategies to boost your organization's cybersecurity efforts. To understand the policies better and evaluate their effectiveness, you can easily access the policy definition pages by clicking on the provided links. Always remember, your expertise plays a crucial role in strengthening the organization's infrastructure and staying ahead of evolving cyber threats. As a security engineer, you're responsible for ensuring the robustness of your organization's security measures. To assist you in this task, you rely on the Secure Score that analyzes security configurations, provides recommendations, and helps you enhance your organization's defenses against potential threats. Hello, and welcome to the video, Explore Secure Score. In this video, we'll explore Secure Score used to analyze security configurations, identify vulnerabilities, and offer actionable recommendations for enhancing the organization's defenses against threats. The Secure Score is the central feature in Defender for Cloud that helps you achieve these goals. This powerful tool consistently evaluates your cross-cloud resources for security issues. It then consolidates all the findings into a single score, allowing you to assess your security situation quickly. The higher the score, the lower the identified risk level, providing valuable insights. When you navigate through the pages of the Azure portal, you'll find that the Secure Score is displayed as a percentage value. It represents your security posture, and the underlying values are conveniently presented alongside it. To enhance your security, look at the Recommendations page in Defender for Cloud. Implement the remediation instructions provided for each issue to address any vulnerabilities. The recommendations are grouped into security controls representing your vulnerable attack surfaces. Remember, your score improves when you resolve all recommendations within control for a particular resource. Review the scores associated with each security control for a detailed view of how well your organization secures each attack surface. To maximize your security control points, ensure that all your resources adhere to the security recommendations within each control. For instance, Defender for Cloud offers multiple recommendations for securing management ports. Removing all of them is crucial to impact your secure score significantly. Let's look at this example. Remediate vulnerabilities, security control. You'll find multiple recommendations to identify and resolve known vulnerabilities within this control group. Now let's dive into the concept of the maximum score. Max score represents the highest points you can achieve by addressing all the recommendations within a control. The maximum score assigned to each control reflects its relative importance and remains consistent across environments. Utilize the max score values to prioritize which issues to tackle first, allowing you to triage your security efforts effectively. Let's talk about the current score. The current score represents the score attained for a specific control at the present moment. The current score is calculated by multiplying the score per resource by the number of healthy resources within that control. Each control plays a role in determining the overall score. The control contributes 2 points to this example's current total secure score. Now let's discuss the potential score increase. Potential score increase refers to the points that can still be obtained within your control. By addressing all the recommendations in this control, your score has the potential to increase by 9%. The potential score increase is calculated by multiplying the score per resource by the number of unhealthy resources. Let's understand how recommendations affect the secure score. Only built-in recommendations impact your secure score. These are the ones that contribute to the calculation of your overall score. Recommendations flagged as preview do not contribute to the secure score calculations. However, it is still essential to address them whenever possible. These recommendations will start contributing to your score when the preview period ends. Preview recommendations are marked with an identifier to distinguish them from the recommendations that directly impact your secure score. To enhance the secure score, addressing the security recommendations listed is crucial. You have 2 approaches. Manually remediate each recommendation for individual resources or utilize the fix option when available for swift resolution across multiple resources. Additionally, you can optimize your score by configuring the enforce and deny options on relevant recommendations. This helps improve your score and ensures your users don't create resources that could harm it. Now let's recap what we've learned in this video. We now know that a security engineer utilizes a secure score to analyze, improve security measures, address recommendations, and maximize the secure score. We learned how secure score analyzes security configurations, finds vulnerabilities, and offers actionable recommendations to strengthen defenses against threats. The secure score is a percentage showing your organization's security posture. The higher the score, the lower the risk level, so it's essential to aim for a high score. The recommendations are categorized into security controls that represent different areas of vulnerability. By addressing all the recommendations within a control, you can improve your secure score even more. The potential score increase is calculated based on the score per resource and the number of unhealthy resources you have. Meet Joan, a skilled security engineer tasked with deploying Microsoft Defender for Cloud. She's passionate about cybersecurity and meticulously plans the implementation, evaluates risks, and trains the team. Joan envisions a future where their cloud environment is fortified, mitigating risks and protecting critical data. Hello, and welcome to the video, Deploy Microsoft Defender for Cloud. In this video, we'll explore the step-by-step process of deploying Microsoft Defender for Cloud, empowering you with the knowledge to strengthen your cloud security. When you access Defender for Cloud in the Azure portal for the first time or enable it via the Application Programming Interface or the API, it automatically becomes free across all your Azure subscriptions. With Defender for Cloud, you immediately get essential cloud security and posture management or CSPM features. These include a secure score, security policies, basic recommendations, and network security assessments to safeguard your Azure resources effectively. Defender for Cloud provides essential multi-cloud CSPM capabilities at no cost. By default, these capabilities are automatically activated for any subscription or account connected to Defender for Cloud. The foundational CSPM features encompass asset discovery, ongoing assessments, and security recommendations for strengthening your posture. It ensures compliance with the Microsoft Cloud Security Benchmark, also known as MCSB, and offers a secure score providing insights into your organization's security status. Unlocking the optional Defender CSPM plan grants you access to cutting-edge posture management capabilities. Benefit from features such as attack path analysis, Cloud Security Explorer, advanced threat hunting, security governance tools, and comprehensive security compliance assessments. Stay ahead with benchmarks, regulatory standards, and custom policies tailored to your organization, industry, or region. The table summarizes the different plans and their cloud availability. Let's have a quick rundown. To begin your journey with Defender for Cloud, ensure you have an active Microsoft Azure subscription with Defender for Cloud enabled. If you don't have a subscription, you can easily sign up for a free one and start. Did you know that when you activate Defender plans for an Azure subscription, all the resources within that subscription automatically receive the same level of protection? Did you know that Microsoft Defender for Cloud leverages monitoring components to gather data from your resources? These extensions are automatically installed when you enable a Defender plan. It's worth noting that each plan has specific requirements for these monitoring components. So, to fully enjoy the advantages of each plan, it's crucial to ensure that the required extensions are deployed to your resources. This way, you can make the most of the benefits each plan provides. Have you checked out the Defender plans? They provide detailed monitoring coverage information. When the monitoring coverage is marked as full, it means all the required extensions are installed. However, if it's labeled as partial, don't worry. The information tooltip will let you know which extensions are missing. Plus, certain plans even allow you to customize specific monitoring settings according to your needs. It's all about giving you control and ensuring comprehensive protection. You can enable Microsoft Defender for storage accounts at subscription or resource levels. You can enable Microsoft Defender for structured query language, also known as SQL, at either the subscription level or resource level. Regarding open source relational databases, Microsoft Defender can only be enabled at the resource level. At the workspace level, explore powerful Microsoft Defender plans like Microsoft Defender for servers and Microsoft Defender for SQL servers on machines. Microsoft Defender for servers includes Microsoft Defender for endpoint. It's an all-inclusive package that combines endpoint detection and response, also known as EDR capabilities, to provide comprehensive server protection. With this powerful combination, you can ensure that your server endpoints are equipped with robust security measures, enabling you to detect and respond to potential threats. With Defender for Cloud, you can effortlessly conduct vulnerability assessments for your virtual machines, container registries, and SQL resources. You can also conveniently view, investigate, and address the findings directly from Defender for Cloud. You can connect your accounts from Amazon Web Services or AWS and Google Cloud Platform or GCP to leverage the robust security features of Microsoft Defender for Cloud. Doing so, protect your valuable resources and workloads on these platforms. Microsoft Defender for Cloud offers some fantastic features. It helps you acquire a bird's-eye view of your security across all your on-premises and cloud workloads. You can apply security policies and constantly check the security of your hybrid cloud workloads to ensure they meet all the necessary security standards. You can gather, search, and analyze security data from various sources, including firewalls and other partner solutions. Microsoft Defender for Cloud offers advanced behavioral analytics and the Microsoft Intelligent Security Graph that can be used to detect and thwart cyber attacks before they even happen. The built-in behavioral analytics and machine learning capabilities of Defender for Cloud can identify attacks and zero-day exploits, ensuring you're well-equipped to combat even the most sophisticated threats. Defender for Cloud also lets you keep a close eye on your networks, machines, data stores, including SQL servers, hosted inside and outside Azure, Azure SQL databases, Azure SQL Managed Instance, and Azure Storage, and cloud services. You can also streamline your investigations with interactive tools and contextual threat intelligence. Defender for Cloud continuously assesses your hybrid cloud environment to analyze risk factors based on controls and best practices defined in the Microsoft Cloud Security Benchmark. When you enable enhanced security features, you gain the flexibility to apply a range of industry standards, regulatory standards, and benchmarks that align with your organization's specific needs. The regulatory compliance dashboard allows you to add and track standards from one centralized location. It simplifies the process of monitoring and managing your compliance status, ensuring you're always in the know. With these recommendations, you can create allow lists and block lists to block malicious software effectively. Additionally, you can enhance your network security by implementing just-in-time controlled access to management ports on Azure Virtual Machines or VMs. This reduces the potential for network attacks by limiting access only when needed. Moreover, the implementing access application control measures significantly minimizes the risk of brute force and other network attacks, keeping your system secure. Container security features offer the advantages of vulnerability management and real-time threat protection of your containerized environments. With this service, you only pay based on the number of unique container images you upload to your connected registry. Once an image has been scanned, you won't be charged for it again unless modified and uploaded. Enjoy comprehensive threat protection for the Azure services essential for all your resources, such as Azure Resource Manager, Azure Domain Name System or DNS, Azure Network Layer, and Azure Key Vault. With Defender for Cloud, you can safeguard your cloud-native assets effectively. This powerful security solution provides unparalleled visibility into the Azure management layer and the Azure DNS layer, enabling it to seamlessly protect your connected cloud resources. Now, let's quickly summarize the key points. First off, Defender for Cloud offers essential cloud security and posture management features. It includes a secure score, which gives you an idea of how secure your environment is, and network security assessments to identify potential vulnerabilities. When you activate Defender plans for your Azure subscriptions, all the resources within that subscription automatically receive the same level of protection. Also, Microsoft Defender for Cloud leverages monitoring components. These components gather data from your resources and help detect cyber attacks. To take security to the next level, you can enhance it by customizing compliance standards according to your organization's needs. You also have the ability to implement network access controls, which allow you to restrict access to certain management ports on Azure virtual machines. Additionally, container security features provide vulnerability management and real-time threat protection for your containerized environments. Imagine a cyber criminal at their computer, relentlessly trying every key on the keyboard to crack the correct password to your account. This is a very simplistic picture of what a brute force attack can look like. Cyber criminals today are more advanced with their hacking techniques as work becomes increasingly mobile. Hello, and welcome to the video. What are brute force attacks? In this video, you'll learn about a brute force attack, how it works, and how to prevent it. Let's begin by answering the obvious question. What is a brute force attack? A brute force attack is a hacking technique in which an attacker tries to gain access to a network or system by guessing the username and password combination through an automated process. It's a trial and error approach. Brute force attacks have been around as long as there have been passwords. They remain popular and are rising due to the shift to remote work. The attacker typically uses a program that generates many login attempts in a short time to try every possible combination of characters until the correct one is discovered. Once successful, the actor can enter the system masquerading as the legitimate user and remain inside until they're detected. They use this time to move laterally, install backdoors, gain knowledge about the system for future attacks, and steal data. This attack can be very effective against weak passwords and security systems without protection against brute force attacks. However, the good news is that brute force attacks are time-consuming and can be detected by security measures such as account lockouts after several failed login attempts. How does a brute force attack work? An adversary may guess login credentials without prior knowledge of system or environment passwords during an operation using a list of common passwords. Password guessing may or may not consider the target's policies on password complexity or use policies that may lock accounts out after many failed attempts. Typically, management services over commonly used ports are used when guessing passwords. Commonly targeted services include the following. Adversaries could also use automated tools to execute brute force attacks, and those lacking the skill to build their own can purchase them on the dark web in the form of malware kits. They can also purchase data such as leaked credentials used in credential stuffing or hybrid brute force attacks. These lists may be offered as part of a package in which the seller includes the lists, automated tools, and other value adds, such as management consoles. Once the attacker sets up their tools and seeds them with the lists, if relevant, the attack begins. Brute force attacks can be conducted with botnets. Botnets are systems of hijacked computers that provide processing power without the consent or knowledge of the legitimate user. Like the malware kits mentioned above, bot kits can also be purchased on the dark web. Let's take a closer look at brute force attack programs and use cases. Brute force programs can be used individually or in combination to launch a successful attack on a target network or system. There are several types of brute force attack programs used by attackers, including what you see here. How do you know a brute force attack has taken place? Here are some indications. Extreme counts of failed sign-ins from many unknown usernames. Never previously successfully authenticated from multiple remote desktop protocol, RDP, connections, or new source IP addresses. Another example is the potential structured query language, also called SQL brute force attempt alert, as shown here. Finally, let's answer the all-important question. How do you protect against a brute force attack? To counteract brute force attacks, you can take multiple measures, such as disabling the public IP address and using one of these connection methods, a point-to-site VPN, a site-to-site VPN, Azure Express Route to create secure links from your on-premises network to Azure. Requiring two-factor or multi-factor authentication, a brute force attack is less likely to succeed when users are required to offer more than one form of authentication, such as a password and a fingerprint or a password and a one-time security token. A brute force attack is less likely to succeed. Limiting login attempts. Implementing CAPTCHA. By the way, did you know that CAPTCHA stands for Completely Automated Public Turing Test to tell computers and humans apart? limiting the amount of time that the ports are open. Implementing IT hygiene by gaining visibility into the use of credentials across the environment and requiring passwords to be changed regularly. Setting up policies that reject weak passwords using these tips, a mix of upper and lowercase letters mixed with special characters. Educating users on best password practices such as avoiding adding 4 numbers at the end and avoiding standard numbers such as those beginning with 1 or 2. Providing a password management tool to prevent users from resorting to easily remembered passwords, and using a discovery tool that exposes default passwords on devices that haven't been changed. Implementing proactive threat hunting. Threat hunting can expose the types of attacks that standard security measures can miss. If a brute force attack has been used to enter the system successfully, a threat hunter can detect the attack even though it's operating under the guise of legitimate credentials. It's time for a recap. In this video, you learned what is a brute force attack, how it works, the indications of a brute force attack, and how it can be prevented. As you might have learned earlier, threat actors actively hunt accessible machines with open management ports. All of your virtual machines, also known as VMs, are potential targets for an attack. The goal to ensure cybersecurity is to reduce the attack surface, which means having fewer open ports. This is where Microsoft Defender for Cloud Just-in-Time, also known as JIT, comes in. Hello, and welcome to the video, Implement Just-in-Time Virtual Machine Access. In this video, you'll learn how JIT VM access is used to lock down inbound traffic to your Azure VMs, reducing exposure to attacks while providing easy access to connect to VMs when needed. When you enable JIT VM access for your VMs, you next create a policy that determines the ports to help protect, how long ports should remain open, and the approved IP addresses that can access these ports. The policy helps you stay in control of what users can do when they request access. Requests are logged in the Azure Activity Log, so you can easily monitor and audit access. The policy will also help you quickly identify the existing VMs that have JIT VM access enabled, and the VMs where JIT VM access is recommended. Let's explore how JIT VM access works. To enable JIT VM access, you must first enable Microsoft Defender for Cloud. Then select a VM that does not have JIT VM access enabled. Under the Settings blade of the desired VM, select Configuration, and then select Enable Just-in-Time. After JIT VM access is enabled for the desired VM, select Open Microsoft Defender for Cloud. On the Just-in-Time VM access page, select the checkbox beside the desired VM. Then select Request Access. On the Request Access page, select the ports you would like to open per VM using the toggle switch. Select Open Ports to finalize the JIT network access request. To change a port, if required, select the ellipsis corresponding to the VM. Then select Edit. On the JIT VM access configuration page, select Add to add a new port. On the Add Port Configuration wizard, enter the desired port and select OK. Then select Save to add the new port. With that, you've completed enabling JIT VM access. That was simple, wasn't it? To summarize, in this video, you learned how to implement just-in-time access for your virtual machines so as to reduce exposure to attacks and provide easy access to VMs when needed.
As you might already know, computer systems that interact directly with users are considered endpoint systems. These systems on devices like laptops, smartphones, and computers should be secured to prevent them from acting as gateways for security attacks. In today's world of bring your own devices, that even means protecting personal devices with access to your business resources. The news is filled with stories about how organizations have leaked personal information. Those accidents often result from poor security practices or deliberate attacks. Hackers access systems by impersonating a real user or inserting malware into a computer or device with authorized network access. Hello, and welcome to the video Understand the Malware Threat. In this video, you'll explore what malware is, how it gets into your computer, and what you can do to protect against it. But first, let's ask, what is a malware? Malware is malicious software intended to cause damage to a computer or network. It often exploits vulnerabilities in software or unsuspecting users who unknowingly install it. Malware comes in several forms, like viruses, worms, and Trojan horses. Let's look at each of these forms a little closely. We will first see what viruses are. A computer virus requires a host to live in, like a live virus. Viruses are bits of code that attach to existing programs and documents or hide in protected areas of your hard drive, like the boot sector. Because they are hidden in protected areas, they can be hard to find and remove. When the infected program is launched, the virus is executed, often without the user noticing anything. It can then perform malicious actions on the user's data or other files. If an infected computer sends a file to another computer, it can spread the virus with the data. This behavior classifies a computer virus. It lives inside other programs and requires human interaction to spread. Some examples of viruses have been I Love You, Shamoon, and the Chernobyl virus, also known as the CIH. Now let's take a closer look at worms. A worm is a piece of standalone software that copies itself through a computer network. The behavior of a worm is similar to that of a virus. It is designed to duplicate itself, but instead of hiding in existing files, a worm is a separate program that can infect other computers without human involvement. A worm often travels over the computer's network, running in the background on an infected computer and using known vulnerabilities in computer software to locate and infect other connected devices. Some examples of worms have been Melissa, CodeRed, and Stuxnet. Finally, we have the Trojan horses. Everyone knows the story of Troy and the wooden horse that was used to invade the city. This malware adopts the same name because it pretends to be something it's not. Trojan horses are considered the most dangerous type of malware because of what they are often designed to do. They are spread by masquerading as useful software utilities a user wants to install. Because the user authorizes the install, this malware will often gain access to the user's files, including sensitive or private data. In addition, Trojan horses will usually install backdoors to let hackers into the computer or keyloggers to capture keystrokes such as passwords or credit card numbers. Unlike other types of malware, Trojan horses aren't designed to replicate themselves widely. They're intended specifically to control or destroy specific computers they infect. Some examples of Trojan horses are GhostRat, Zeus, and Shedden on Android. Do you know how malware gets installed though? There are several ways malware can get onto a computer. There's a direct install. Most software is delivered over the internet today. Users are conditioned to download and install software from a variety of sources. Malware can get installed without the user's knowledge or through an authorized download that's been tampered with. This approach also applies to infected drives, such as USB keys, being inserted into a computer. Then there is security vulnerability. It is a defect or bug in running software, such as a browser. It might even be in the operating system and allow the installation of malware onto the computer. In this case, the malware exploits the security flaw to obtain administrative access or to get infected files onto the computer. Finally, malware can get into the computer through the back door. It can be installed through a design opening left in the software. These backdoors are often placed there for testing and debugging. If left in place and released into production, it can be exploited to gain access to the computer or network. This brings us to the essential question: how best can you protect against malware? Here are several key strategies you can use with Microsoft Defender for Cloud to protect your computers and network from malware. First, you can keep your servers up to date with the latest OS fixes and versions. Defender for Cloud will automatically alert you when monitored systems are unpatched. Second, you could install anti-malware such as Microsoft Anti-Malware for Azure Cloud Services and virtual machines, also known as VMs, to help identify and remove viruses, spyware, and other malicious software. Third, you can use firewalls to block network traffic. Defender for Cloud identifies open traffic to your VMs and servers and provides instructions to activate the built-in firewall capabilities of Azure. Fourth, you could integrate your anti-malware solution with Defender for Cloud to monitor the status of the anti-malware protection. This last step is crucial to a complete monitoring plan. Defender for Cloud highlights issues like detected threats and insufficient protection that make your VMs and computers vulnerable. Using the information on endpoint protection issues, you can plan to address any identified issues. Time to recap. In this video, you learned what malware is and its different forms, how malware can get installed on your computer, the most effective ways of protecting against malware.
Congratulations! You've completed learning about implementing Microsoft Defender for Cloud, configuring Microsoft Defender for Cloud policies and recommendations, and protecting your systems and networks from brute force attacks. Let's recap what you've learned. Initially, you were provided an overview of Microsoft Defender for Cloud, a cloud-native application protection platform with security measures and practices designed to protect cloud-based applications from various cyber threats and vulnerabilities. You learn that you can connect your Amazon Web Services or AWS and Google Cloud Platform or GCP cloud resources to Microsoft Defender for Cloud and enjoy seamless security management. Next, you were introduced to the cyber kill chain model, an intrusion detection approach driven by intelligence. You learned about the 7 phases of the cyber kill chain model: reconnaissance, weaponization, delivery, exploitation, installation, command and control, or C2, and actions on objectives. These phases form a cohesive end-to-end process represented as a chain, where disrupting any step can disrupt the entire sequence. Next, you learn that Microsoft Defender for Cloud fulfills 3 vital needs as you manage the security of your resources and workloads in the cloud and on-premises. First, it continually assesses your security posture. Second, Microsoft Defender for Cloud recommendations secure your workloads. And third, it defends your workload in real time. Then you learn to customize various global Microsoft Defender for Cloud settings using the Environment Settings option on the Microsoft Defender for Cloud menu. You learn that there are 4 areas you can influence: Defender plans, integrations, auto-provisioning, and email notifications. Moving forward, you learn that Microsoft Defender for Cloud is fully integrated into Azure Policy. With Azure Policy, you can define specific requirements for your Azure subscriptions, tailoring them to match your workload type or the sensitivity of your data. You also learn that Microsoft Defender for Cloud monitors policy compliance across your subscriptions using a default set of security policies such as enabling secure transfer to storage accounts, provisioning an Azure AD administrator for SQL servers, and utilizing Azure AD for client authentication. Your learning did not stop at concepts. You had the exciting opportunity to practice what you learned through a hands-on exercise where you learned to implement Microsoft Defender for Cloud. Next, you explored how Microsoft Defender for Servers offers comprehensive protection for Windows and Linux servers across diverse environments. You were acquainted with the 5 stages involved in the successful deployment of Microsoft Defender for Servers. Start protecting resources. Enable Defender for Servers. Protect AWS or GCP machines. Protect on-premises servers. Enable Foundational Cloud Security Posture Management or CSPM. Then, you learn that the Microsoft Cloud Security Benchmark has guidelines for OS hardening, which has led to security baseline documents for Windows and Linux servers. Defender for Cloud includes 2 recommendations that use the guest configuration feature of Azure Policy to check whether the configuration of Windows and Linux machines in your environment meets Azure Security Baseline configurations. 1. Vulnerabilities in security configuration on your Windows machines should be remediated, and 2. Vulnerabilities in security configuration on your Linux machines should be remediated. Next, you learned how to effectively set up and customize Microsoft Defender for Cloud policies to enhance your organization's defense against cyber threats. Microsoft Defender for Cloud helps keep your subscriptions safe and protects important data with security initiatives and policies. Further integration into Azure Policy ensures you can manage and customize those security initiatives, including the default Microsoft Cloud Security Benchmark. Progressing further, you learn that Secure Score is the central feature in Microsoft Defender for Cloud that consistently evaluates your cross-cloud resources for security issues. The higher the score, the lower the identified risk level. You learned that when you activate Defender plans for your Azure subscriptions, all the resources within that subscription automatically receive the same level of protection. Next, you went on to learn how to monitor your security status with Microsoft Defender for Cloud recommendations, which help identify the current security state of your created workloads. Microsoft Defender for Cloud reviews your security recommendations across all workloads, uses algorithms to determine the criticality of each recommendation, and calculates the secure score. Once again, you had the opportunity of a hands-on exercise where you practiced configuring Microsoft Defender for Cloud policies. Next, you learned about brute force attacks, a hacking technique in which attackers attempt access to a network or system by guessing the username and password combination. You learn that brute force login attacks commonly target management ports to gain access to a virtual machine, VM, or server. You also learn that brute force attacks can be prevented using multiple measures, such as disabling the public IP address, requiring two-factor or multi-factor authentication, limiting login attempts, implementing CAPTCHA, implementing IT hygiene, setting up policies that reject weak passwords, implementing proactive threat hunting, and limiting the amount of time ports are open. The final approach, limiting the time ports are open, is what Microsoft Defender for Cloud implements on your behalf. Management ports such as remote desktops only need to be open when connected to the VM, for example, to perform management or maintenance tasks. You learn that enhanced security features in Microsoft Defender for Cloud support just-in-time VM or JIT VM access. When JIT VM access is enabled, Microsoft Defender for Cloud uses Network Security Group Rules or NSG rules to restrict access to management ports when they aren't in use, so attackers can't target them. So in a nutshell, JIT VM access locks down inbound traffic to your Azure VMs, reducing exposure to attacks while providing easy access to connect to VMs when needed. You had another chance to engage in a hands-on exercise where you practiced enabling JIT VM access. You also learned about the forms of malware, viruses, worms, and Trojan horses. You learned that you can protect your systems and networks from malware by keeping your servers up to date, installing anti-malware using firewalls to block network traffic, and integrating your anti-malware solution with Microsoft Defender for Cloud. Next, you discovered that Microsoft Defender for Cloud monitors the status of anti-malware protection for your VMs by identifying security issues that might make your VMs and computers vulnerable to malware attacks. Phew, that was a fantastic learning experience. You're now prepared to advance to the next stage and tackle the graded assessment for this module. Good luck as you tackle the module quiz.
Imagine that you work as a security operations center or a SOC analyst in a large enterprise. Your organization wants to upgrade its security management. As part of your responsibilities, you were asked to evaluate security information and even management or SIEM solutions that can help in both the on-premises and a multi-cloud environment. During your research, you read about Microsoft Sentinel and want to determine whether it could be the right SIEM solution for your organization. Hello, and welcome to the video on what is Microsoft Sentinel. In this video, you will learn about Microsoft Sentinel and when to use it. You will also enhance your knowledge of the critical features and capabilities of Microsoft Sentinel, including how and when to deploy it. You will also learn about Microsoft Sentinel's Zero Trust model and its help in threat intelligence. Let's begin. Before deep diving into Microsoft Sentinel, let us understand the most commonly used term, SIEM. A SIEM system is a tool that an organization uses to collect, analyze, and perform security operations on its computer systems. These systems can be hardware appliances or applications or both. SIEM is also responsible for detecting threats to your organization by analyzing the massive volumes of data generated by all of your system's logs. What facilities does the SIEM system allow you to perform? It allows you to collect and query logs, do correlation or anomaly detection, and create alerts and incidents based on your findings. Next, let's look at the SIEM system's different functionalities. Log management helps to collect, store, and query the log data from resources within your environment. Alerting provides a quick look inside the log data for potential security incidents and anomalies. Visualization provides a visual insight into the log data through Microsoft Graphs and dashboards. Incident management helps to create, update, assign, and investigate the identified incidents. Querying data provides a rich query language similar to that for log management that you can use to query and understand your data. Now let's dive deep into the core concept of Microsoft Sentinel. Microsoft Sentinel is a scalable cloud-native SIEM and security orchestration, automated response, or SOAR solution. Microsoft Sentinel delivers intelligent security analytics and threat intelligence across the enterprise by collecting data from virtual sources. It provides a proactive solution for detecting and investigating alerts and threat visibility using built-in machine learning and Microsoft Threat Intelligence. It also offers automated threat responses using playbooks and integrating Azure Logic apps. What are the features of Microsoft Sentinel? You don't need to install servers on-premises or in the cloud to run Microsoft Sentinel with a traditional SIEM solution. Microsoft Sentinel is a service that you deploy in the Azure portal in no time. You can integrate with other cloud services like authorization and automation too. Let's go deeper into understanding Microsoft Sentinel. Microsoft Sentinel offers limitless cloud scale and speed to address your security needs. Let's examine what would happen if Microsoft Sentinel worked as the first SIEM as a service. This will provide the power of the cloud and artificial intelligence to help the security operation teams to identify and stop cyber attacks in advance. In addition, Microsoft Sentinel builds and monitors the Zero Trust model. The solutions in Microsoft Sentinel are bundled with pre-configured content for a specific dataset. The Zero Trust or Trust Internet Connection 3.0, also called TIC 3.0 solution, includes a workbook, analytics rules, and a playbook, which provides an automated visualization of Zero Trust principles. Microsoft Sentinel integrates with Microsoft 365 solution and correlates millions of signals from products such as Azure Identity Protection, Microsoft Cloud Apps Security, Microsoft Defender for Identity, formerly called Azure Advanced Threat Protection, also called ATP, Microsoft Intune, and Azure Information Protection or AIP. What are the services that Microsoft Sentinel does provide? It helps to collect data at a cloud scale across all users, devices, applications, and infrastructure, both on-premises and in multiple clouds. Moreover, it detects previously undetected threats and minimizes them using analytics rule and unparalleled threat intelligence. The analytics rule frame user accounts and IP addresses found in the logs as trackable entities, note information, and packet for further investigation. It also investigates threats with artificial intelligence and hunts for suspicious activities at scale, tapping into years of cybersecurity work at Microsoft. It accesses the severity of incidents and identifies the IP addresses to know the source of malicious activity through automation rules and playbooks. And it responds to incidents rapidly with built-in orchestration and automation of everyday tasks. This helps to remediate security threats detected by Microsoft Sentinel. It also helps to set a data retention policy for a table in log analytics. By default, all the workspace tables inherit the workspace's interactive retention setting and have no archives policy. But you can do this within the free trial pricing tier. Now, where do you use Microsoft Sentinel? You know that Microsoft Sentinel is a solution for performing security operations on your cloud and on-premises environments. You can use Microsoft Sentinel to collect event data from various sources and perform security operations on that data to identify suspicious activity. Microsoft Sentinel helps integrate threat intelligence, import threat intelligence or TI into Microsoft Sentinel by enabling data connectors to various TI platforms and feeds, view and manage the imported threat intelligence in logs and in the threat intelligence blade of Microsoft Sentinel, detect threats and generate security alerts and incidents using the built-in analytics rule templates based on your imported threat intelligence, visualize key information about your imported threat intelligence in Microsoft Sentinel with the threat intelligence workbook. How do you decide that the Microsoft Sentinel is the right fit for you? Microsoft Sentinel has capabilities such as cloud-native SIEM with no servers to provision, so the scaling is effortless, integration with the Azure Logic Apps service and the hundreds of connectors, benefits of Microsoft Research and machine learning, free key log sources, and support for hybrid cloud and on-premises environments. But your organization will have certain specific requirements when you start investigating for Microsoft Sentinel, such as support for data from multiple cloud environments and features and functionality required for the SOC without too much administrative overhead. With this, you have come to the end of this video. Let's summarize. In this video, you first learned about SIEM, then deep dived into learning about Microsoft Sentinel, why it is valuable, and when you can use it. You also learned about Microsoft Sentinel's Zero Trust model and its importance in threat intelligence. And you came to know that Microsoft Sentinel is a good choice.
You know that Microsoft Sentinel helps you to enable end-to-end security operations. It starts with log ingestion and continues to automate responses to security alerts. Hello, and welcome to the video, How Does Microsoft Sentinel Work? In this video, you will learn about the key features and components of Microsoft Sentinel. Microsoft Sentinel helps you achieve your goals as the Security Operations Center Analyst or SOC Analyst. For example, it allows you to ingest data from your cloud and on-premises environments, performs analytics on that data, manages and investigates any incidents that occur, and responds automatically using playbooks. What are the key features and components of Microsoft Sentinel? First is data and connectors. This feature allows you first to ingest your data into Microsoft Sentinel. Select a button to add services, such as Azure Activity Logs, but the other service, such as syslog, requires a configuration. The data connectors cover mostly all sources, such as syslog, Common Event Format, or CEF, Trusted Automated Exchange of Indicator Information, or TAXII for Threat Intelligence, and Amazon Web Services, or AWS. Another feature and component of Microsoft Sentinel is log retention. Once your data connectors get ingested into Microsoft Sentinel, your data gets stored using log analytics. Log analytics lets you query your data using the Custo Query Language, or KQL. KQL is a rich query language that gives you the power to dive into and gain insights from your data. The next feature and component are workbooks. You can use workbooks to visualize your data within Microsoft Sentinel. Let's consider workbooks as dashboards. You can use your data's underlying KQL query to build each dashboard component. You can also edit the built-in workbooks within Microsoft Sentinel to meet your requirements or create new ones. For example, if you have used Azure Monitor workbooks, this feature implements Microsoft Sentinel. Now, let's look at the analytics alerts. You have data connectors and data when you reach the analytics alert state. At this stage, it is wise to have proactive analytics across your data to notify you about threats. You can enable built-in analytics alerts within your Microsoft Sentinel workspace and edit a few as per your requirements. At the same time, other alerts are built on machine learning models that are proprietary to Microsoft. You can also create custom and scheduled alerts. What will the threat hunting feature and the component of Microsoft Sentinel do? SOC Analyst uses built-in investigation queries to investigate suspicious activity. They can also create their questions and integrate Microsoft Sentinel with Azure Notebooks. It also provides example notebooks for advanced investigators who want to use the full power of a programming language to investigate their data. Now, what are incidents and investigations? You can view a created incident when your enabled alert gets triggered. Microsoft Sentinel allows you to do standard incident management tasks, like changing status or assigning incidents to individuals for investigation. Microsoft Sentinel also has investigation functionality, so you can visually investigate incidents by mapping entities across log data along a timeline. And the last feature and component are automation playbooks. You can automate some of your security operations and make your SOC more productive with the ability to respond to incidents automatically. Microsoft Sentinel allows you to create automated workflows or playbooks in response to events. You can use this functionality for incident management, enrichment, investigation, or remediation. These capabilities are known as Security Orchestration Automation and Response, or SOAR. Now that you have come to the end of this video, let's summarize. In this video, you learned about the ingestion of data from your cloud and on-premises, and features and components of Microsoft Sentinel, such as data connectors, log retention, workbooks, analytics alerts, threat hunting, incidents and investigations, and automation playbooks. Hello, and welcome to the video, Data Connections in Microsoft Sentinel. In this video, you will learn about the prerequisites for Microsoft Sentinel and how to connect data connectors to Microsoft Sentinel. You will also learn about the types of data connectors and the data connection techniques in Microsoft Sentinel. Before we delve into data connections thoroughly, let's look at the prerequisites for Microsoft Sentinel. These prerequisites are active Azure subscription, log analytics workspace, contributor and reader permissions, additional permissions for specific data sources, subscription for Microsoft Sentinel. Let's begin with the concept of the data connectors in Microsoft Sentinel. To set up Microsoft Sentinel in Azure, you must first connect with security sources to comprehend the data connectors in Microsoft Sentinel. Numerous connectors are available for Microsoft solutions through Microsoft Sentinel. They offer real-time interaction with Microsoft Threat Protection Solutions and Microsoft 365 sources, such as Azure Active Directory, Microsoft Defender for Identity, also called ATP, and Microsoft Cloud App Security. Do you know how to connect data in the Data Connectors page? To do so, in the Azure portal, you must select Data Connectors within Microsoft Sentinel, then search for any connector, for example, Azure Active Directory Identity Protection, and select it. Now, select the Open Connector page. Next, in the Configuration section, select Connect to connect data with Microsoft Sentinel, and the system will send the alerts to the Microsoft Sentinel workspace. Are you familiar with Microsoft Sentinel's various data connection techniques? Let's first look at the service-to-service integration data connection technique. Few services, such as Amazon Web Services or AWS and Microsoft services, use the Azure Foundation for a unique integration. Few solutions connect with a click, such as Amazon Web Services, CloudTrail, Azure Activity, Azure AD Audit Logs and Sign-ins, Azure AD Identity Protection, Azure Advanced Threat Protection, Azure Information Protection, Microsoft Defender for Cloud, Cloud App Security, Domain Name Server, Microsoft 365, Microsoft Defender ATP, Microsoft Web Application Firewall, Windows Firewall, Windows Security Events. The following technique uses APIs to access external solutions. You can use APIs to connect data sources that are accessible through the connected data source. The APIs collect specific types of data by connecting to Microsoft Sentinel and sending it to Azure Log Analytics. Then, there is a technique known as external solutions through an agent. An agent can use the syslog protocol to link Microsoft Sentinel to any other data source supporting real-time log streaming. The agent-based log analytics transforms Microsoft Sentinel CEF logs into a format that log analytics can read. Depending on the types of appliances, an agent is installed on a remote server or directly on the device. Next, let's look at the agent connection options. The first prerequisite is connecting your device to Microsoft Sentinel. You must install the agent on a dedicated on-premises or virtual machine, or VM, to facilitate communication between your external device and Microsoft Sentinel. You can automatically deploy the agent if your dedicated machine is a new VM in Azure that you are creating. However, you can manually deploy the agent on a system already running an Azure VM in another cloud or on-premises. Now you have come to the end of this video. Let's summarize. In this video, first, you learn the prerequisites for Microsoft Sentinel and how to connect data connectors. Then, you learned about the types of connectors available for data connectors in Microsoft Sentinel. And lastly, you understood different methods for data connections. Imagine you are an IT security analyst responsible for monitoring and analyzing the collected data. As a part of your responsibility, you want to notice what's happening across your environment. To do so, you have connected your data sources to Microsoft Sentinel. As a result, you get instant data visualization and analysis from your connected sources. Hello, and welcome to the video on Visualize Microsoft Sentinel data using workbooks. In this video, you will learn to visualize data in incidents, automation, data connectors, and analytics. You will also learn about workbooks, adding a query, and creating detections. Let's begin. Microsoft Sentinel provides workbooks that give complete access to tools available in Azure. With this, you can access built-in tables and charts to provide analytics for your logs and query. Let's consider analyzing your environmental activities in the Microsoft Sentinel dashboard. To do so, you must first log in to the Azure portal, then search for Microsoft Sentinel and select it. You can view incidents, automation, data, and analytics cards on the dashboard page. To refresh the dashboard data, select Refresh. The data are pre-calculated for each dashboard component to enhance efficiency, and the top of each section displays the refresh time. Let's first select the Incidents card. The incident is a collection of connected notifications you can examine and address. To match warnings with occurrences, Microsoft Sentinel employs a fusion technique. On the Incidents page, at the top left, you can view the number of incidents. At the top right, you can view incidents organized by severity and closed incidents by classification. The bottom left represents the graphical presentation of incident status by creation time with an interval of 4 hours. You can also view a link to manage incidents. And the bottom right represents the mean time to acknowledge an incident and the mean time to close. Here, you have a link to Analyze SOC Efficiency Workbook. Next, in the Automation card, at the top, you can view a summary of the automation rules activity. Below the summary is a progress bar summarizing the number of actions performed by automation. And at the bottom, you can view the count for the active automation rules with a link to configure automation rules. Now, let's view the data on the data card. On the left, you can view the graphical representation of the data received in 24 hours, compared to the earlier 24 hours, and anomalies detected in that period. The top right represents the summary of data connectors. Unhealthy connectors are connectors with errors, while active connectors are connectors with data streaming into Microsoft Sentinel and query included in the connector measured it. Below data connectors, you can see Threat Intelligence, or TI, by type records. You can also view a link for Manage Connectors at the bottom left. And the last card on the dashboard page is Analytics. You can view the number of analytics with their current status on the Analytics page. Here, you have a link to Manage Analytics rules. What else is there to visualize the data? There are built-in workbooks in Microsoft Sentinel. To enable you to explore the events produced by those services, built-in workbooks offer integrated data from your connected data sources. The built-in workbooks contain on-premises Azure Activity Events, Azure Active Directory, or Azure AD. The workbook helps analyze firewall traffic, correlates your firewall data with threat events, and highlights suspicious circumstances across entities. You can customize workbooks easily. Next, how to visualize data in the workbooks. To do so, select Workbooks in the left navigation menu of the Microsoft Sentinel. A workbook page will appear. Within the My Workbooks tab, you can view all created workbooks, while in the Templates tab, you can view the gallery of built-in workbooks available for installation. If you want to view a specific workbook, type a keyword in the search box. You will find the workbooks related to your search. Additionally, workbooks offer details on traffic trends and filter results. You can edit workbooks by selecting Edit. Next, let's visualize data in the logs. Logs is a repository to store data and configuration information. It allows the creation of queries to filter important information, which gets used to create analytics rules and detect threats. You can access the Logs page by selecting Logs icon on the Workbooks page, or selecting Logs on the left navigation menu in the Microsoft Sentinel. Upon selecting Logs, you will land on the Logs page. Here, you can mainly explore queries, settings, and help on the Logs page. The left navigation pane of the Logs page displays tables, which presents data collected from the logs in a tabular format, while the Query tab shows the results of the queries. Now, let's add a new query. To do so, select a plus sign on the Query page. A new window will open for queries. Select your query from Query Templates, or write it in the Query pane. How do you write a query? To write a query or retrieve data from the logs, you can take help from Kusto Query Language or KQL. KQL allows users to build, save, and use interactive analytics on the gathered data to visualize and examine significant data. Microsoft Sentinel makes use of KQL. Select Solution from the Group By dropdown to explore the saved queries. Solution queries filter the most common queries you can use to filter the data. From the Solution Queries list, you can either select Run the query or Organize the query in the Favorites section by selecting the star icon. The Tables pane on the left menu groups logs from different solutions into tables. You can expand the solution group and observe all the collected logs. You can also select one of the logs from the Tables pane and preview the data or add that logs to the Favorites section. Once you set up all the information for your query, select Run. Your query will run in the system. Now, let's visualize the data in the detections. When the data sources are linked to Microsoft Sentinel, the detections assist in examining threats within the organization. To view detections, go to Analytics in the left navigation menu within Configuration Blade of Microsoft Sentinel and select the Rule Templates tab. This tab contains all the Microsoft Sentinel built-in rules. It is important to note that when you create a new detection, leverage the built-in detections from Microsoft security researchers, which will tailor to your connected data sources. Now you have come to the end of this video. Let's summarize. In this video, you have visualized data on the Microsoft Sentinel dashboard. Then you visualize data available in the workbooks and logs. You also learned to run queries in detail. In a large enterprise, the IT operations team monitors and maintains its cloud infrastructure hosted on Microsoft Azure. To streamline their operations, they leveraged Azure Workbooks, a powerful tool for creating custom dashboards and reports. With this, they gained better visibility, improved decision-making, and enhanced efficiency in managing the Azure environment. Let's dive deep into this. Hello, and welcome to the video, Create Workbooks to Explore Microsoft Sentinel. In this video, you will learn the after effects of connecting sources to Microsoft Sentinel and the importance of workbooks. You will also learn workbook scenario and how to create workbooks in Microsoft Sentinel. Let's begin. Once you connect your sources to Microsoft Sentinel, you can monitor your data using Microsoft Sentinel integration with Azure Monitor workbooks. Microsoft Sentinel helps to create custom workbooks for your data and explore built-in workbook templates to gain insights across your data. With the help of workbooks, you can combine text, analytics queries, Azure metrics, and parameters into rich interactive reports. In addition, you and your team member can edit the workbooks with access to the same Azure resources. Next, let's look at the helpful scenarios for workbooks. Explore app utilization. This scenario aids in comprehending app usage traffic in terms of user counts, retention, and conversion rates. Workbooks incorporate numerous visualizations and analyses, unlike other usage analytics solutions. Describe the new function. Key interaction count and other metrics can be used to quantify the effectiveness of the new feature. Results sharing. You can share the outcomes of the app's new tests with your team. In addition, you can describe the test objectives using metrics and analytics queries. Report creation. Creating an app utilization report will help monitoring app usage. With the goal of preventing future interruptions, you can integrate data and talk with your team about the next actions. Do you know how to create a new workbook? You can use an existing workbook as a base for your new workbook or create a new one. To do so, select Workbooks on the left navigation menu within Microsoft Sentinel. Then select Add Workbook. A new workbook page will appear. Now select Edit. An editing page will open. To edit the workbook, select Edit on this page. If you want to edit the query, you can click Logs icon. This will redirect you to the Log Analytics page to create or edit the queries. Edit the workbook details and select Done Editing. Select the Save icon to save the workbook. A Save As page will open. On this page, enter the required details and select Apply. You will view the created workbook on the Workbook dashboard page. You can also share a workbook through a link or as an email. You must remember that the link recipients should have access to view workbook and its resources in the Azure portal. The recipients must have a contributor role to edit or update the resources. Now you have come to the end of this video. Let's summarize. In this video, you have learned to monitor data using Microsoft Sentinel integration with Azure Monitor workbooks, workbook scenarios, and how to create workbooks. Alex is a skilled security analyst who oversees the incident response team. Today, he wants to create rules in Microsoft Sentinel, which are crucial in creating incidents. Alex knows each rule's requirements, triggers, and actions to ensure timely incident creation and effective response. As he delves into this important task, he is determined to create a robust framework to fortify his organization's defense and stay one step ahead of potential threats. Let's help Alex. Hello, and welcome to the video on Enable Rules to Create Incidents in Microsoft Sentinel. In this video, you will learn about the alerts in Microsoft Security Solutions and a prerequisite for it. Then you will learn to enable rules using analytics within Microsoft Sentinel. And lastly, you will learn to create incidents automatically using data connections. Let's begin. Commonly, Microsoft Security Solutions are connected with Microsoft Sentinel to receive alerts. When you connect a Microsoft solution to Microsoft Sentinel, any alert generated in that service will be stored as primary data in Microsoft Sentinel within the Security Alert table. You can use these data as is. Also, whenever you receive an alert in the connected Microsoft Security Solutions, it will be easy to configure Microsoft Sentinel automatically to create incidents. But a few Microsoft Security Solutions, such as Microsoft Defender for Cloud Apps and Microsoft Defender for Identity, formerly called Azure Advanced Threat Protection, also called ATP, do not automatically create incidents in Microsoft Sentinel. In such a situation, Microsoft Security Incidents enable analytic rules that help to create incidents in Microsoft Sentinel. To do so, you must use the built-in rules offered by Microsoft Sentinel to identify the connected Microsoft Security Solutions that create Microsoft Sentinel incidents automatically in real time. Once you create the rules, you can edit them to establish more specific options to filter alerts that Microsoft Security Solutions sends. Hence, Microsoft Sentinel records such alerts. Next, let's understand how to create a rule in Microsoft Sentinel. First, log into the Azure portal and search Microsoft Sentinel in the search box, and select Enter. A Microsoft Sentinel page will appear. On the Microsoft Sentinel page, under Configuration Blade, select Analytics from the left navigation menu. You can view the available active rules here. Now select the Rule Templates tab. You can view all the Analytics rule templates here. If you want to search for more rule templates, select Content Hub. In the search box, for example, type the keyword Microsoft Security for the rule type. Select the Analytics rule template from the appeared list you want to use and select Create Rule. An Analytics rule wizard page will appear. For example, select Microsoft Defender for Cloud from the Microsoft Security Service dropdown. Then choose Medium in the Filter by Severity field. Next, select Review and Create. Review the entered details on this page and select Save to save the rule. You can view the saved rule within the Active Rules tab. Further, if you want to edit the created rule, select the created rule and then choose Edit. Follow the earlier steps to edit the entered details on the Analytics Rule Wizard page. You must note that you can create multiple Microsoft Security Analytics rules per Microsoft Security Service type. This action does not create duplicate incidents since each rule is unique. Also, if an alert matches more than one Microsoft Security Analytics rule, it takes just one Microsoft Sentinel incident. Let's look at the steps to create a new Microsoft Security rule to filter alerts from different Microsoft Security services in Microsoft Sentinel. On the Analytics dashboard page, select Create, and then select Microsoft Incident Creation Rule from the dropdown. Enter the required details within the Analytics Rule Wizard page and select Review and Create. On this page, review the entered information and select Save. Your created rule will appear on the Analytics dashboard page within the Active Rules tab. You can further edit this rule by selecting a created rule and then Edit. You can follow the previous steps to edit the rule. Next, let's understand how to create automatic incidents in Data Connection. To do so, select Data Connectors from the left navigation menu under the Configuration blade on the Microsoft Sentinel page. Type the keyword on the Data Connectors page to search the available data connectors. Let's select the Azure Active Directory Identity Protection Data Connector. Now, select the Open Connector page. You can select Connect to connect Microsoft Security Solution data source. Then, in the Create Incidents section, select Enable to enable the default analytics rule that automatically creates incidents from alerts generated in the Connected Security service. You can edit this rule within Active Rules tab under Analytics of Microsoft Sentinel. With this, you have come to the end of this video. Let's summarize. In this video, you have first learned Microsoft Sentinel allow creating incidents automatically. Then, you learned the prerequisites for Microsoft Security Solutions. Lastly, you learned to develop rules within Microsoft Sentinel under Analytics, enabling automatic incident creation in the data connections. John is a Security Operations Center analyst, or SOC analyst, overwhelmed with security alerts and regular events. As a result, many alerts get ignored and unattended, leaving the organization vulnerable to unnoticed attacks. Most of these alerts and incidents conform to specific recurring patterns and defined sets of remediation actions. John's also tasked with essential remediation and investigating the incidents he can handle. How do you automate such activities to help John work more efficiently and dedicate his time to exploring activities? Hello, and welcome to the video on Configure Playbooks in Microsoft Sentinel. In this video, you will learn about playbook definitions, templates, and how to customize playbooks in detail. Let's begin with understanding the concept of playbooks. A playbook is a collection of remediation actions that can run from Microsoft Sentinel. It helps to automate and orchestrate the threat response. It runs manually on entities, and alerts run automatically in response to specific alerts or incidents triggered by an automation rule. For example, if an account and device get compromised, a playbook can isolate the device from the network and block the account till the SOC team receives a notification of the incident. How do you access playbook templates? A playbook template is a pre-built, tested, and ready-to-use workflow customized to meet users' requirements. It helps to create playbooks from scratch for new automation scenarios. Technically, a playbook template is an Azure Resource Manager, or ARM, template consisting of several resources. The SOC analysts use these templates or get ideas for the leading automation. The Microsoft Sentinel community used to share most of these templates and was able to find them as a Microsoft Sentinel GitHub repository. Some of these get integrated into Microsoft Sentinel solutions. First, log into the Azure portal and go to Microsoft Sentinel. Select the created Microsoft Sentinel workspace or create a new one. Select Automation from the left navigation menu. An automation page will appear. Select the Playbooks Templates Preview tab. To simplify your playbook template search, you can view the available filters such as Trigger, Logic App Connectors, Entities, Tags, and Source Name. How do you configure a playbook from an existing template? It is important to note that the playbooks have prerequisites to follow. Certain playbooks depend on the other playbooks for their actions. These playbooks are known as nested playbooks. However, certain playbooks demand the installation of an Azure function or a customized Logic Apps connector. Hence, a Deploy to Azure link will direct you to the general ARM template deployment procedure to fix this. To configure a playbook within the Playbook Templates tab, search for the required playbook and select it. Next, select Create Playbook. A Create Playbook page will open. In the Basics tab, enter the mandatory details such as subscription, resource group, region, and the playbook name. Next, select Review and Create tab. First, the system validates the entered data on this page in the Basics and Connections tab. You can review the data entered, and if there are any changes, you can go back and modify them by selecting a particular tab. Select Create and Continue to Designer. Your playbook will start getting processed. A Logic App Designer page will appear. you can view the workflow design process for Playbook. You can also add a new action for each connector by selecting the plus sign. Now, from the navigation menu, select API Connections and select the connection name. A Microsoft Sentinel reset page will appear. Select Edit API Connection from the left navigation menu to edit it. An Edit API Connection page will appear. Edit the information if required and select Save. You will get a notification message, Successfully Edited API Connection, and the edited name will get displayed on the overview page. You can create a new connection in the Logic App Designer by authenticating relevant instructions. If you find any such connectors, expand its boxes from the list of connections and select the created connection. For example, if you select Managed Identity Connection for Microsoft Sentinel, then grant permission to the new playbook on the Microsoft Sentinel workspace and save the playbook. The saved playbook will appear in the Active Playbooks tab. You can run this playbook automatically or manually. Now you have come to the end of this video. Let's summarize. In this video, you have learned about a playbook and its uses. Then you explored the playbook templates. And lastly, you configured playbook. With the changing digital world, Microsoft Sentinel has taken a significant leap to control your organization's security posture. With its feature, you can fortify your defenses, streamline incident response, and maintain the highest level of security. Hello, and welcome to the video on Turn on Auditing and Health Monitoring for Microsoft Sentinel. In this video, you'll explore how to turn on auditing and health monitoring features and verify the settings. Interestingly, as you turn on the auditing and health monitoring feature, data tables such as Sentinel Health and Sentinel Audit get generated. These tables support specific resources such as Analytics Rule, data connectors, automation rules, and playbooks with Azure Logic Apps workflow. Do you know how to turn on your workspace's auditing and health monitoring feature in Microsoft Sentinel? First, go to Azure Portal and select Microsoft Sentinel. Select the created workspace on the Microsoft Sentinel page or create a new one. On the Microsoft Sentinel's Workspace Overview page, within Configuration, select Settings from the left navigation menu. A Settings page will appear. On this page, select the Settings tab. And scroll down to the Auditing and Health Monitoring section. Next, expand this section to view the available options in it. You can see two options, Enable and Configure Diagnostic Settings. Let's first select Enable. It will help to enable auditing and health monitoring across the resource types and send the generated data to the workspace. And the button turned to Enabled. Next, select Configure Diagnostic Settings link to view the appropriate diagnostic settings added in the background for the enabled workspace. Upon selecting this, it will enable health monitoring only for the data connectors, automation resources, or to configure advanced options, like different places to send the data. Select Add Diagnostic Setting. Fill in the relevant details on the diagnostic setting page and select Save. You can verify the saved settings on the Microsoft Sentinel Logs page by running a query on the Sentinel Health table. That's all in this video. Let's summarize. In this video, you learned how to turn on auditing and health monitoring for Microsoft Sentinel and verify the added settings. Cybersecurity attacks are a severe concern in the current digital environment, and the most secure systems are susceptible to attacks too. Microsoft Sentinel is critical in protecting the organization's infrastructure and data in such situations. Hello, and welcome to the video on Hunt and Investigate Potential Breaches. In this video, you'll learn Cyber Kill Chain, a method of locating attacks. You'll also examine how Microsoft Sentinel and the cloud investigate suspected breaches, discover the underlying reason for the potential violation, and tips for threat hunting using notebooks in Microsoft Sentinel. Additionally, you'll learn about standard investigation procedures and how to download security content from the community. Let's begin with exploring today's digital actions and threat landscape. Most cyber attacks follow the cyber kill chain, a standardized procedure and pattern. By deploying security measures in the cyber kill chain, organizations take strategic action to fight against these threats. Defense employs the best tactics together with the cyber kill chain at every stage because attackers can bypass any step through various exploitation techniques. Now, let's understand the suspected breaches in the cloud and Microsoft. Sentinel environments are sought out and investigated. The Azure subscription's initial step is to turn on Microsoft Defender for Cloud. It includes capabilities for ongoing threat identification and monitoring. To analyze the security alerts produced by Microsoft Defender for Cloud, you must then routinely monitor security alerts. Following that, you should actively investigate the alerts as you receive them by examining the information, such as the affected resources, the severity level, and the suggested actions. To gain insight into security events and spot potential breaches, you can set up unique analytics rules to find specific hazards pertinent to your area. Then, you may use Azure Monitor logs to gather and examine log data from various sources, including network appliances, virtual machines, or VMs, and Azure Active Directory, Azure AD. To reduce the attack surface, you can install network security best practices like network security groups, NSGs, web application firewalls, WAFs, and distributed denial of service, DDoS, prevention plans. Then, you can regularly conduct vulnerability assessment using tools like Microsoft Defender for Cloud's built-in vulnerability scanner or third-party solutions. Following that, you can establish access controls to impose rigid access restrictions based on the principle of least privilege, or POLP, or PULP. To lower the risk, you must periodically check user permissions and eliminate unused access rights. You can also create an incident response planning process for the suspected breach in the Azure environment. Finally, you should update your knowledge of Microsoft's best practices to improve your security posture. What are the root causes of prospective security threats? Microsoft Sentinel's investigation tools can help you find a specific entity on the interactive graph and inquire about it in depth to learn the exact cause of the potential security problem. In such cases, a search and query tool, a built-in query, may help you. Before raising the alarm, it enables you to search for security issues across the organization's data source. Additionally, within the analytics rule, you can develop unique detection rules based on your query, and your security incident responders will receive alerts. Next, how will notebooks help to improve Microsoft Sentinel's threat hunting? Microsoft Sentinel supports Jupyter Notebooks for machine learning, which have complete data visualization and analysis libraries. You can use notebooks to increase the collected data range, which helps to accomplish numerous tasks. For example, use Python machine learning features to conduct analytics that Microsoft Sentinel does not provide. Create data visualizations not already included in Microsoft Sentinel, like bespoke timelines and process trees. Integrate data from sources outside Microsoft Sentinel, like an on-premises dataset. Threat hunters, Tier 2 or 3 analysts, incident investigators, data scientists, and security researchers also have notebooks, but they require advanced coding skills and a steeper learning curve. Further, notebooks provide functionality for data enrichment, research, visualization, hunting, machine learning, and queries to both Microsoft Sentinel and external data. Let's now consider how to download security-related community content. Microsoft Sentinel's community is a potent tool for automated threat detection. Security analysts add and create workbooks, playbooks, and hunt queries. They can publish these feature items for the community to use. You can get sample content from the private community GitHub repository to develop unique workbooks, hunt queries, notebooks, and playbooks for Microsoft Sentinel. Let's now examine the fundamental procedures for an investigation. The first step is to gather information about the possible intrusion, for example, suspicious activity logs, network logs, or user reports. Following that, you should alert the relevant authorities, for example, Microsoft's internal security or designated incident response team. After that, you must appropriately preserve all the evidence pertinent to the investigation. The incident response team will then extensively analyze the data. To investigate the breach, they might employ network monitoring, system forensics, and log analysis methods. Identifying damaged systems, compromised data, or potentially exposed instances of Microsoft's infrastructure will help you evaluate the breadth and effect of the incident. After that, you must assess the breach's containment and mitigation to protect against additional harm and recognize any hazards. Remediation and rehabilitation come last. Once you identify the immediate threats, concentrate on corrective actions like removing malware, restoring backups, or enhancing security measures to stop future occurrences. Now you have come to the end of this video. Let's summarize. In this video, first, you learned cyber kill chain. Then you explored the potential breach's root cause and resolved the threat using Microsoft Sentinel's notebooks. And lastly, you learned the standard investigation procedure and how to download security content for the community. As a security team member, your primary task is to search for specific events and users within a particular time frame. To do so, you can use Microsoft Sentinel's search job feature to search archived logs. Hello, and welcome to the video on search across long time span in large datasets. In this video, you will learn about the steps to search jobs and how to restore and delete datasets. Let's get started. To run a search job, you require specific permissions for the Log Analytics workspace, such as Microsoft.operationalinsights/workspaces/tables/write and Microsoft.operationalinsights/workspaces/searchjobs/write. Do you know how to search for jobs in the Microsoft Sentinel? Let's look at it. First, log into the Azure portal to access the search job feature. Then select Microsoft Sentinel and select the appropriate workspace. Go to the General in the left navigation menu and select Search. On the search page, enter a search name in the search box and select Start. You can see that an Advanced Custo Query Language, or KQL, editor logs page has appeared. Select Run to modify the KQL. Updated search results are visible here. Next, if you are satisfied with the appeared data, select Ellipses and then toggle for Search Job Mode. And select the appropriate time range and choose Apply. It would be best to resolve KQL text appearing in red in the editor line to select Search Job. Enter a new table name to store search job results and select Run a Search Job. It is important to note that the search time depends on the size of the target dataset. Once your search gets completed, select Done to close the search pane. You will return to the Search Overview page to view the search job. Now, let's look at how to view searched results. On the Search Overview page, select the Save Searches tab. Then select a search card and choose View Search Results, Preview. On the Search Results Preview page, you can view all the results that match your original search criteria. Select Columns in the left pane. Select the checkbox in Choose Columns pane and select Apply to add the results to your result view. Now, select Add Filters to refine your searched results. Next, if you want to tag events, add notes, and attach these events to an incident for your future reference, select any search result and select Add Bookmark. You can see a blue highlighted icon for your bookmarked result. Next, let's look at the steps to delete the searched results. To do so, select a search result you wish to delete, and then select Delete. Now, select Yes on the Delete Search Table prompt message. Once you delete the search job from the saved searches, it is not visible anymore on this page. Now, how do you restore the historical data from the archive logs? Select Restore Data to investigate the searched results within the Saved Search tab. A restoration page will appear. Specify a target table and time range. Look at the limitations for the data you want to restore on the restoration page, and select Restore. You can view restored search results within the Restoration tab. Now you've come to the end of this video. Let's summarize. In this video, you learned how to search large datasets, delete and restore the dataset. Imagine Sarah is a cybersecurity analyst specialist in threat modeling with a passion for protecting digital landscapes. She aims to safeguard organizations from the ever-evolving threat landscape by meticulously identifying potential vulnerabilities and designing robust countermeasures. As we delve into the threat modeling world, join Sarah on a journey to illuminate the path to safe cyberspace. Hello, and welcome to the video overview of threat modeling. In this video, you will explore the different phases and tools of threat modeling. Then you will also learn about the threat modeling process, the threat model, and the template section. Let's get started with the threat modeling phases. Threat modeling is a technique used by analysts with a working knowledge of information security. This technique has 4 phases. Each phase contains essential steps to create a data flow diagram and analyze the potential threats. The first is the design phase, where you can gather plenty of necessary data to develop a data flow diagram at the appropriate depth level. It also provides a comprehensive picture of the operating system, or OS, lists all the services it uses, and enumerates all the presumptions it makes about the environment and default security settings. The second is a break phase, where you can use a threat modeling methodology to analyze the data flow diagram and identify potential security risks for your system. Furthermore, it aids in recognizing the most typical dangers and defenses. You can detect specific threats through spoofing, tampering, repudiation, info disclosure, denial of service, and elevation of privilege framework, also called the STRIDE framework. And choose between protecting the system and understanding the attacker-focused techniques. The third is the fix phase, which assists in approaching each issue with the appropriate security controls. Each STRIDE threat has a corresponding security control with various options for functions and types. Besides, you can evaluate every threat with a prioritization matrix or security bug bar, use a bug management solution to track each danger as a job or work item, develop security control suggestions that correspond to STRIDE threats. Choose one or more security control types and functions to counteract each threat. And finish tasks. The fourth is the verify phase, before the system's deployment. It ensures that criteria are satisfied, corrects presumptions, identifies issues, and applies security controls. Additionally, you can verify that the system satisfies all previous and new security requirements, configure the cloud provider, OS, and components to meet security requirements, ensure that all issues get addressed with the appropriate security controls, and run the system through manual and automated verification before deployment. Now let's understand the threat modeling tool. The threat modeling tool is crucial to Microsoft's Security Development Lifecycle, or SDL. Its key responsibility is to view and mitigate potential security issues when they are easy to use and maintain. This tool's design provides simple instructions to create and analyze threat models. When a user launches this tool, the most recent updates get configured. The threat modeling tool enables to communicate about the security design, analyze designs for potential security issues, and suggest and manage mitigations for security issues. The threat modeling tool's methodology entails generating a diagram, identifying issues, mitigating them, and validating each case. Do you know how to start the threat modeling process? The threat modeling tools team works to enhance the user interface and functionality. Hence, you will see specific threat parameters when you open the threat modeling tool. Let's explore the threat model section of this diagram. You can view the Microsoft Developer Network Forum, or MSDN forum, for SDL with the feedback, suggestions, and issues. It lets you view other users' activities and read their suggestions. Next, create a model. You can open a blank canvas to draw a diagram and choose a template for your model. Then, Template for New Models will help create a new model. The main template is the Azure Threat Model template, which includes stencils, threats, and mitigations related to Azure. Further, Open a Model will open previously saved threat models. The Recently Opened Models tool helps to open recent files. You can use your computer or OneDrive to open the saved files. And Getting Started guide will help to open the Microsoft Threat Modeling tool main page. Next, what's there in the template section? You can create a blank template with Create New Template option. You can also take help from the existing template to create the new one by choosing Open Template. Now you have come to the end of this video. Let's summarize. In this video, you have learned about the phases of the threat model and the threat modeling tools. Then you learn the threat modeling process using the threat model and template. Congratulations on completing this module. This module focused on the concepts to configure and monitor Microsoft Sentinel. Let's recap what you learned. You began this module with Microsoft Sentinel, where you learned that Security Information and Event Management, or SIEM system, is an organization's tool to collect, analyze, and perform security operations as its computer systems and their functionalities. Then, you dove into the concept of Microsoft Sentinel, a scalable, cloud-native SIEM and security orchestration automated response, or SOAR, solution. You also explored Microsoft Sentinel services, such as collecting, detecting, investigating, and responding. You also learned features and components of Microsoft Sentinel, such as data connectors, log retention, workbooks, analytics alerts, threat hunting, incidents, and automation playbooks. Next, you learned a sample workspace design for Microsoft Sentinel, which gave you insights about workspace requirements, such as multiple tenants and regions with European data sovereignty requirements, single tenants with multiple clouds, multiple tenants with multiple regions, and centralized security. While enabling Microsoft Sentinel, you first added workspace in the Microsoft Sentinel, then installed a solution from the Content Hub, established a data connector, generated activity data, and reviewed its status. Then you explored steps to connect data connectors in Microsoft Sentinel with prerequisites. You also learned the types of data connectors and their techniques. Next, you comprehended how to control the ingested data through ingestion time data transformation. It allows filtering and enriching the output tables even before executing any queries. That's not all. You also had an opportunity to check out hands-on exercises to connect Microsoft Defender for cloud alerts to Microsoft Sentinel. As you progressed, you visualized data in Microsoft Sentinel using workbooks for incidents, automation, data, and analytics on the dashboard page. You also visualized data in workbooks, logs, and added a new query. Next, you learned steps to create workbooks to explore your data in Microsoft Sentinel and built-in workbook templates to gain insights across your data. Then, you used Azure Monitor workbooks to visualize and monitor your data by using the existing workbook templates or creating a new one. Then you learned to work with anomaly detection analytics rules, where you explored customizable anomaly detection analytics rules in Microsoft Sentinel. Next, you learned steps to enable rules to create incidents in Microsoft Sentinel with the existing rule or create a new one for the incident. You also learned steps to create incidents automatically from data connectors. Further, you learned steps to create custom analytics rules to detect threats with a scheduled query, define rule query logic, and configure settings. You also explored event grouping and rule suppression, configured the incident creation settings, established automated responses, and created the rule. You also learned to configure playbooks from the Playbook Template tab within Automation. A playbook template is an Azure Resource Manager, or ARM template, consisting of several resources. Next, you learned steps to use playbooks with automation rules in Microsoft Sentinel, which helped you to triage incidents in Microsoft Sentinel. You can automatically assign incidents to the right personnel and add tags. Then you learned steps to turn on the auditing and health monitoring feature in Microsoft Sentinel. Further, you learned steps to create watch lists in Microsoft Sentinel, such as uploading a watch list from a local folder, adding a new one, or uploading a watch list created from a template, Preview. You can also create a large watch list from a file in Azure Storage, Preview, view the watch list status, download the watch list template, and delete and recreate the watch list in a local folder's log analytics view. That's not all. You also learned about the cyber kill chain in hunting and investigating potential breaches. You also examined how Microsoft Sentinel and the cloud investigate suspected breaches, discover the underlying reason for the possible violation, and tips for threat hunting using notebooks in Microsoft Sentinel. Further, you explored steps to investigate threat incidents, using an investigation graph to understand the scope and identify the root cause of a potential security threat by correlating relevant data with any involved entity. Then you learned to search for the long time span and extensive data using the Search Job feature to review the archive data. Next, you explored threat modeling, where you learned different phases of threat modeling such as design, break, fix, and verify. Alongside, the threat modeling tools methodology entails generating a diagram, identifying issues, mitigating them, and validating each case. Further, you learned Microsoft Security Development Lifecycle, or SDL, threat modeling approach in Threat Modeling Tool. You explored steps to use tool to develop a threat model for the security process, analyzed, and reported the threat. In the feature overview and threats, you learned the theory of spoofing, tempering, repudiation, information disclosure, and denial of service, or STRIDE model, in detail and different steps to create a threat model. Once again, you had an opportunity to check out the features and test the steps to deploy investigation threats through hands-on exercises. What an incredible learning experience that was! You're now ready to move to the next step of attempting the graded assessment for this module. Good luck with the module quiz!
You have explored various fascinating topics in the Manage Security Operations course. How much information are you able to retain? A course summary allows you to review and internalize key concepts and improve retention. You learned that the AZ-500 exam tests your knowledge and skills to manage security operations, such as creating and managing Azure Monitor alerts and using Microsoft Defender for Cloud for security management and threat protection. Let's recap what you learned in this course. You started your journey in week 1 with Azure Resource Monitoring, which helps to improve security controls, conduct regular audits, and implement effective monitoring mechanisms to enhance the organization's security posture. What are the monitoring options available in Azure? Azure Monitor, Microsoft Defender for Cloud, and Microsoft Sentinel are Azure solutions that help monitor an organization's services. The configure and monitor metrics and logs taught you the metrics supported by Azure Monitor metrics, the sources from which Azure Monitor collects metrics and user logs. In the Enable Log Analytics, you explored the various log analytics access points within the Azure portal and steps to access log queries and log analytics workspace. Moving forward, you explored steps to create basic Azure Monitor log queries through log analytics and Custo query language, or KQL. You also came across the concept of full stack monitoring in Azure, a comprehensive approach for monitoring, triaging, and diagnosing applications, infrastructure, and security issues. Then you move to week 2. This week started with a recap of Microsoft Defender for Cloud, which combines multiple security measures, promotes development security operations, or DevSecOps, and protects servers, containers, storage, and databases. Next, you learn about the cyber kill chain by exporting the stages of the cyber kill chain and its phases. You also learn to implement Microsoft Defender for Cloud to boost cloud security by scanning your cloud setup, finding and addressing vulnerabilities, and keeping your workloads safe in multi-cloud and hybrid environments. You also learned centralized policy management with Microsoft Defender for Cloud to simplify policy management, enforce custom security rules, and monitor compliance. That's not all. You also learned to configure Microsoft Defender for Cloud policies, manage and implement its recommendations, and robust security measures to safeguard sensitive data and maintain uninterrupted business operations. Then you explored Secure Score to analyze security configurations, find vulnerabilities, and offer actionable recommendations to strengthen defenses against threats. Then you came across the theory of brute force attack, how it works, and what are the preventive measures. While implementing just-in-time virtual machine access, you learned that it locks inbound traffic to Azure Virtual Machines, or Azure VMs, reduces exposure to attacks, and provides easy access to VMs when needed. Then you learned the theory of malware threats, how they come, and how to prevent them. You also explored steps to configure malware detection by logging into the Azure portal, going to Microsoft Defender, installing anti-malware in a new VM, and adding it as an extension once it gets deployed. Now you have come to week 3. And it started with Microsoft Sentinel's definition and services such as collecting, detecting, investigating, and responding. Data connectors, log retention, workbooks, analytic alerts, threat hunting, incidents, and automation playbooks are features and components of Microsoft Sentinel. You learn steps to enable Microsoft Sentinel by adding a workspace in Azure, installing a solution from the Content Hub, establishing a data connector, generating activity data, and reviewing its status. As you progressed, you learned to visualize data in Microsoft Sentinel for incidents, automation, data and analytics on the dashboard page. Next, you learned steps to create workbooks for your data and explored built-in workbook templates to gain insights across your data. You can also visualize and monitor your data using existing workbook templates or creating a new one. That's not enough. You also learn steps to enable rules to create incidents in Microsoft Sentinel with the existing rule or create a new one for the incident. You also reviewed the steps to configure playbooks from the Playbook Template tab within automation. Further, you learned steps to create watch lists in Microsoft Sentinel, such as uploading a watch list from a local folder, adding a new one, or uploading a watch list created from a template preview. That's not all. You also explored hunting and investigating potential breaches to identify root causes, how to resolve threats using notebooks, and the standard investigation process. You also learned threat modeling, its phases, and tools in detail. You also learned the theory of spoofing, tampering, repudiation, information disclosure, and denial of service or STRIDE model, and the different steps to create a threat model. Interestingly, this course allows you to check the features and test the steps through hands-on exercises. Great job on completing your learning journey. You are now ready to move on to the course project. The project offers an exciting chance for you to put your new learning into practice, receive valuable feedback from peers, and provide feedback on their work in return. Rediscover the thrill of conquering challenges and relish that remarkable sense of triumph. Graded assessments offer a chance to showcase your abilities and relish the satisfaction of overcoming academic challenges. They affirm your growth, boost self-confidence, and pave the way to continued success. Hello, and welcome to the video about the graded assessment. In this video, you'll be introduced to important details related to the graded assessment at the end of this course. In the course Manage Security Operations, you would have mastered the concepts covered and completed the hands-on exercises, reinforcing your learning. It's now time for the final graded assessment, which will test your understanding of managing security operations and fortifying your organization's security posture. The graded assessment evaluates your knowledge and understanding of the course content and helps hone key exam preparation skills such as effective time management and managing test anxiety. The graded assessment also provides valuable insights into the areas you need to improve. You can apply your learnings to develop a robust exam preparation strategy for the AZ-500 certification exam. You may be curious about several aspects of the graded assessment, including the type of questions, the scoring methodology, and the assessment duration. Let's dive deeper into the specifics to understand these details better. So what kind of questions can you expect in the final graded assessment? The final graded assessment consists of multiple choice questions. You will often be presented with a scenario that you must carefully analyze to answer the question correctly. You will notice that the question formats are similar to the knowledge checks and the module quizzes you completed. We have designed this question format to familiarize you with the types of questions frequently encountered in the AZ-500 exam. Each question in the graded assessment carries a value of 1 point with a maximum of 20 points that you can earn. It's important to note that there is no negative marking for incorrect answers. Even if you are uncertain about a particular question, it's worthwhile to attempt it to the best of your ability. Don't hesitate to make an educated guess if necessary. What is the assessment duration? To ensure that you have ample time to carefully consider each question and provide thoughtful responses, we have crafted the final graded assessment to last 1 hour, giving you approximately 3 minutes to answer each of the 20 questions. Unlike the AZ-500 exam, there's no pressure to complete the assessment within the stipulated time, as there's no timer that will restrict you from continuing after the allotted time has lapsed. Nevertheless, we strongly advise completing the assessment within an hour to practice for the pace expected in the AZ-500 exam. The graded assessment allows you to navigate back and forth between questions and modify your answers before final submission. This feature allows you to review your work, make necessary changes, and ensure you're fully satisfied with your responses before submitting the assessment. It's important to note that you must achieve a minimum score of 80% to pass the assessment. This means you'll have to answer at least 16 of the 20 questions correctly. Take time to carefully read each question before selecting your response. As you prepare for the graded assessment, remember you can still revisit and reinforce key concepts. Use this time to refresh your knowledge about configuring and managing Azure Monitor, using Azure Monitor application insights, diagnostic logging, implementing Microsoft Defender for Cloud, and applying security baselines for servers. Additionally, consider reviewing topics such as configuring security center policies and enabling just-in-time virtual machines or JIT VM access. It's also a good idea to revisit topics on Microsoft Sentinel, using Azure Monitor workbooks to visualize and monitor data, using playbooks with automation rules, investigating incidents with Microsoft Sentinel, and the threat modeling overview. Remember, you have the option of taking the AZ-500 certification exam at a test center or from the comfort of your own home. To prepare effectively for the AZ-500 certification exam, we recommend creating a similar environment for this graded assessment. This entails finding a quiet space to take the exam and closing all other applications and browser pages to simulate the exam environment. Good luck with the final graded assessment of the course Manage Security Operations. Congratulations! You have completed the course Manage Security Operations. This is the 6th course in a series of 7 courses in the Microsoft Azure Security Engineer Associate Professional Certificate Training Program. This course is part of the preparation for the AZ-500 Microsoft Azure Security Technologies exam. The content you learned in this course aligns with the Manage Security Operations area of the AZ-500 exam. Recall that approximately 25 to 30% of the exam questions pertain to this particular skill area. Having learned the concepts in this course, you are now well prepared to answer questions on creating and managing Azure Monitor alerts and using Microsoft Defender for Cloud for security management and threat protection. You explored Azure Monitor, its features, and the monitoring options available in Azure. Then, you learned about enabling log analytics and configuring properties for diagnostic logging. Next, you learned about implementing Microsoft Defender for Cloud, applying security baselines for servers, configuring Microsoft Defender for Cloud policies, and enabling just-in-time virtual machine or JIT VM access. Then you learned about connecting Microsoft Defender for Cloud alerts to Microsoft Sentinel, using Azure Monitor workbooks to visualize and monitor your data, and using playbooks with automation rules in Microsoft Sentinel. Finally, you learned about investigating threats with Microsoft Sentinel. Another milestone achieved. You have now moved one step forward in your preparation for the AZ-500 exam. Remember to refer to the Microsoft website for the latest updates on the AZ-500 exam. Before we wrap up this course, watch the video on the next steps in this training program. See you there. You have made it to the final video of the course, Manage Security Operations. Take a moment to acknowledge and celebrate this remarkable accomplishment. As a next step, you will move on to the course titled Capstone and Practice Exam. This is the final course in the series of 7 courses that prepare you for the AZ-500 Microsoft Azure Security Technologies exam. The Capstone and Practice Exam course includes a comprehensive recap of the concepts covered in the 6 courses you have completed. The course concludes with a program-level ungraded peer review project and a practice exam. Let's explore what will be covered in this course. In the recap of Course 1, Secure Access with Azure Active Directory, you will brush upon concepts related to identity and access management, configuring and managing Azure Active Directory or Azure AD, creating and managing users and groups in Azure AD, authentication methods, including multi-factor and passwordless authentication, hybrid identity, and connecting on-premises AD with Azure AD. In the recap of Course 2, Identity Protection and Governance, you will review key concepts concerning Azure AD Identity Protection, configuring Azure AD Privileged Identity Management or PIM, the Shared Responsibility Model, Azure Cloud Security Advantages, Azure Hierarchy of Systems, Azure Built-in Policies and Initiatives, enabling Azure Role-Based Access Control or Azure RBAC, source logs, and deploying Azure Blueprints. Next, in the recap of Course 3, Implement Platform Protection, you will revisit important concepts related to the Defense in Depth strategy, configuring Distributed Denial of Service or DDoS protection, deploying an Azure firewall, configuring VPN-forced tunneling, creating user-defined routes and virtual network appliances, network security groups and application security groups, and securing web applications, including Azure Application Gateway, Web Application Firewall, or WAF, and Azure Front Door. You'll also brush upon host and container security concepts, deploying privileged access workstations, creating virtual machine templates, enabling remote access management, deploying disk encryption, Windows Defender, and Azure security benchmarks. In the recap of Course 4, Secure Your Applications, you'll refresh your knowledge of Azure Key Vaults, Key Vault keys and secrets, the Microsoft Identity Platform, single-page applications, web apps that sign in users, call APIs, configure authentication in daemon and non-interactive apps, application security with Azure AD, and other Microsoft tools, configuring app registration, Microsoft Graph, configuring and enabling managed identities, and deploying web app certificates. Then in the recap of Course 5, Secure Your Data at Rest, you'll revisit concepts related to Azure Storage Access, deploying shared access signatures or SAS, testing key rollover, creating stored access policies, and configuring Azure AD user account authentication for storage. You'll also have a refresher on storage service encryption, storage endpoints, enabling structured query language database authentication or SQL database authentication, configuring Azure AD authentication, enabling Defender for SQL, securing your data in transit, at rest and on display, configuring dynamic data masking, implementing transparent data encryption, and deploying an always encrypted implementation. Finally, in the recap of Course 6, Manage Security Operations, you'll strengthen your grasp on concepts such as Azure Monitor, enabling log analytics, configuring properties for diagnostic logging, implementing Microsoft Defender for Cloud, applying security baselines for servers, configuring Microsoft Defender for Cloud policies, and enabling just-in-time virtual machine or JIT VM access. You'll also review the core concepts of connecting Microsoft Defender for Cloud alerts to Microsoft Sentinel, using Azure Monitor workbooks, using playbooks with automation rules in Microsoft Sentinel, and investigating threats with Microsoft Sentinel. Following the recap of the 6 courses, you will have the opportunity to work on a challenging capstone project. The capstone project will be a hands-on culmination of all the knowledge you've acquired throughout this training program. This peer-reviewed project will span 90 minutes and will not be graded. You'll be presented with a project scenario and the guidelines to complete the project successfully. Once you complete the project, you will be required to upload your submission for peer evaluation. You will then peer review the submissions assigned to you, explore the project solution walkthrough, and engage in an optional discussion with your peers to share the insights gained from the project. Finally, you'll have the chance to assess your learnings and come out with flying colors. This training program concludes with a practice exam, which will test your skills on all the concepts learned in this program. The scenario-based questions will mimic the format of the AZ-500 Microsoft Azure Security Technologies exam. This practice exam is designed to last 120 minutes, giving you approximately 3 minutes to answer each of the 40 questions. In this video, you learn that your next step is the 7th and final course in this training program, Capstone and Practice Exam. Ready to take your Azure security skills to the next level? See you in the next course.